Hello everyone, welcome to my YouTube channel Concept Clear. In today's class, we will discuss about symmetric key ciphers. In second unit, cryptography network security, second unit, the topics are symmetric key sniffers. In that one, the first topic is block ciphers. In that first one is block ciphers. What do you meaning of block cipher? Block cipher is a mechanism of encryption and decryption. Encryption and decryption. It is nothing but if encryption, it is a block cipher is nothing but it is a combination of encryption and decryption. Okay, and block ciphers is an encryption decryption method. A block cipher operates on blocks of the plain text. Okay, for example, if you take any plain text message, that will be divided into number of blocks. Okay, see here, the plain text is divided into number of blocks. Each block it will generate an individual cipher text block. Okay, according to our plain text, that message will be divided into number of blocks. For example, here I am taking the plain text message is A, B, C, D, E, F. It is the plain text message. That message will be divided as block 1 is A, B, C, block 2 is D, E, F. Okay, in block cipher, every plain text block will be encrypted as secure message. For example, here ABC is the first block plain text, DF is the second block plain text. Here ABC is a plain text message will be encrypted like $@0. This is the cipher text message. And what about DF? DF will be encrypted as and percentile and hash symbol. Okay, assume this is the example. This is the basic example. This is the this is the plain text, original plain text. That plain text is divided into number of blocks, and each block is encrypted as the cipher text. This is called block cipher. Each block can have a size. Okay, generally the blocks will be divided like in 40 bits, 56 bits, 64 bits, 128 bits and 256 bits. These are the several sizes of blocks. Okay, the plain text block size is equal to cipher text. What is the main thing here? What is the plain text size we are taking? The same size of the cipher text will be created after block cipher operation. Okay, see here, by using secret key, the plain text are converted into cipher text. Here I am explaining very clearly with example. Okay, see here, this is the plain text message. What is the block here? This is the plain text message will be, I am written as a blocks. Okay, this is the first block, block 2, block 3, block 4, block 5, block 6. Okay, these are the several blocks we have plain text message. With the help of the secret key, this is the secret key. Okay, with the help of the secret key, this plain text message is converted as cipher text. Here, how many plain text blocks we have? 6 plain text blocks. And what is the cipher text size also? 6. And A will be converted as dollar, B as the @ C is 0, D is and E is the percentile, F is the hash symbol. Okay, this is the block cipher conversion from plain text to cipher text. If we use the same secret key for this cipher text, we will convert from cipher text to plain text at receiver. At receiver, the plain text message again will be here encryption with help of the secret key and here decryption with help of the key. That is called block cipher. See, here we are performing encryption operation. Here we are performing hello. This is the function operation. Here, what is the plain text we are taking the block cipher? That is the block 1. Okay, here initialization of vector, it is a X. Generally, we will take the XOR function as F, and after that, we will apply block cipher encryption with help of the key. Here, after the plain text will be plain text, applied the XOR operation function. After that, it comes to the encryption block. Here, with help of the secret key, we are creating the cipher text. In the first round, in the first block. Here, what is the cipher text is generated here? That cipher text is considered as the function for, that is the considered as the initialization vector for second round in the second block. Here the plain text of the second block, block 2 data will be coming here, and what is the output of the first block, that will be taken as the initial vector, and here with help of the vector, with help of the key, we are performing encryption and the second time. Here after that again it will be generate some ciphertext. Okay, again it will be created the some ciphertext. That ciphertext will be displayed here, as well as the same ciphertext data we will consider as initial vector for third block. Okay, here the block 3 plain text is taking here. Here we initialize vector ciphertext of the previous round with help of the secret key. Again we are performing the encryption algorithm. Again after that we are getting the ciphertext. This operation will be performed several rounds based on our algorithm. The same operation will be repeated several. Data encryption standard algorithm is the best example for DS algorithm. Here block cipher have three principles. The first one is number of rounds and design of the function, and third one is the key scheduler algorithm. We will discuss one by one. Okay, what is meaning of number of rounds? Number of rounds is nothing but it is depending on the algorithm. Each and every algorithm have several rounds of operation. In each round, we will perform the encryption with secret key. Okay, see here, based on the algorithm, the rounds are depends on the algorithm. Each and every round we have to several rounds. Based on the more number of rounds, if you have performed the more number of rounds, that much harder to hacker. How many rounds we are performing, based on that, that message will be created as the more securely. Okay, clear. Next, if 10 rounds algorithm easy to hack when you are compared with 20 rounds algorithm. Okay, if you are performing 10 rounds means, and we are performing 20 rounds means, what is the more value? 20 rounds means it is the more secure than 10 rounds. Okay, that is the number of rounds. Okay, the second function is, the second principle is design of the function. Design of the function means here we need a function f which will be complicated to understand, A function will be very much complicated understand, that much more than time hacker will be take as to decode the data. Generally, we need a function to perform the some operations. Whatever the function we are taking, that should be more complicated. If it is easy to, then hacker will be hacked, our message will be very easily. Generally, we will take non-linear functions. By comparing linear and non-linear functions, we will take the non-linear functions for perform the operation, and as well as the design the function. The last one is key scheduler algorithm. What is the meaning of key scheduler algorithm means? It is very careful. Okay, we should be very careful when you are generating a key, because key is very important at the time of encryption as well as the decryption. If key have minor change, then lot of changes in the ciphertext. Based on the key only, the encryption message will be converted as ciphertext. If the key value will be changed, the ciphertext message will also change. Okay, this is about the block cipher principles. Okay, clear? If you have any doubts, please ask me in comment section, and also share our videos with your friends and subscribe our YouTube channel Concept Clear. This is nothing but DS is a symmetric key block cipher. Okay, DS is a symmetric key block cipher. What is the meaning of symmetric key? In any algorithm, we will use single key for encryption as well as decryption. Those type of algorithms are called symmetric key algorithms. And what is the block cipher means? The data, the plain text will be divided into number of blocks, then those type of ciphers is called block cipher. Here, what is the DS is? DS is the semantic key block cipher. It means these two things will be implemented in DS algorithm. Okay, clear? It was developed in early 90s, published by NIST. Okay, NIST means National Institute of Standard and Technology. Okay, DS algorithm is a landmark in cryptography algorithm. Why? Because before that there is a small little bit of techniques, but after developing DS only, This is the one of the major encryption algorithm. Okay, DS is not using currently. Why? Because it is vulnerability. Okay, if it is vulnerability means if any hacker, if you use DS algorithm, the secure message also we can hack by using several techniques. Okay, so it is not using currently, and the DS algorithm is replaced by AES algorithm, advanced encryption standard by in 2001. We will discuss AES in the next class. Okay, now DS works based on the Feastal cipher structure. What is the meaning of Feastal cipher structure? Means it is a structure. Wait a second. What is Feast? This Feastal cipher structure means it is a structure where the data. Okay, see, it is a Feastal cipher structure. It means when the plain text is coming, the plain text will be divided into two subparts. Two subparts. Here we will apply encryption algorithm. Here also we will apply encryption algorithm with help of the secret key. After encryption, the data will be swapped. It means this is the left side data, this is the right side data. After encryption, again the left side data will goes to right side and the right side data will goes to left side. Again, we will apply for encryption. Again, these both will be swapped, left side to right side. Again, left side and right side data will be swapped. Okay, this is the Feastal cipher structure. Okay, this logic will be implemented in DS algorithm. So it are saying that this is the Feastal cipher structure. Okay, in this one, in DS algorithm, the plain text size is 64 bits. And what is the block ciphers? Block ciphers means what is the size we are taking as input data. The same size of the data will get the secure message. The ciphertext message also same size of data. Here we are taking the plain text is 64 bits means what is the ciphertext also? It be a 64 bits. Okay. Next, how many rounds in the DS algorithm we will execute it? Sorry, in DS algorithm it will perform slowly 16 number of rounds. It means 16 times permutations and substitutions will be performed in DS algorithm. Okay, clear? Next, what is the size of the key? The size of the key is 64 bits. Actually, the size of the key is 64 bits, but it will be converted as 56. And in that 56 also, we'll use 48 bits for round operation. We'll use the 48 bit of the round operation. The size of 64 bits, number of rounds are 16. For each round, we are providing a subkey. For each round, we are providing a subkey of 48 bits. Subkey of the 48 bits. That means from 64 bits, we are generating 16 number of subkeys. For each round, we have to generate a subkey. Okay, clear? Next, and what is the DS algorithm diagram? Okay, see, this is the structure of the DS algorithm. Okay, here left side we are taking the plain text and right side we are taking the key. This is the key is 64 bit. Okay, first see the left side part. What is the left side happening? What are the operations are happening at left side? Okay, don't focus on right side immediately. Okay, here this is the plain text. This plain text is coming. Here plain text will be taking as initial permutation function. Here where you are taking the plain text went to the initial permutation function. Here 64 plain text bit going to initial permutation function. What is the initial permutation function? This is a function which will be change the bits position. It will change the bits position. For example, bits will be like this 1, 2, 3, 4, 5, 6, 7, 8 and next one 9, 10 up to like this the bits will be stored. Okay, and last one is 63, 64. This is the bits. Okay, these bits position will be changed in initial permutation. How it will be changed? I will explain after end of the in this topic only. I will explain how the bits will be changed. Okay, after that, after initial permutation, what is the output? That is the input to the round one operation. This is the output. What is the operation? What is the output of this initial permutation value? That is the input to the round one operation. Here, round one operation it performs the round one operation with help of the 48 bit key 1. Okay, already I told that initial size is 64 bits. Initial size is 64 bits will be converted as initial size is 64 bits will be converted as 56. Again, in that 48 bits will use for round operation. Okay, I will explain how it will be. Okay, next, after performing round operation 1, what is the output that will be taken as 2 input to the round 2. Okay, and after that round 3, after that round 4, like that the same operations will be performed up to 16 rounds, up to 16 rounds, and after 16 rounds the data will be divided into 232 bits, and these left side part and right side part will be simply perform the swap operation. The 32 bits here, the output is 64 bits. This 64 bits will be divided into two parts, and the left side part and right side part will be simply perform the swap operation. Okay, after that again 32 bits will be divided into 32, but after performing swap operation again it becomes the 64 bits, right? Next, after that it will apply to inverse initial permutation. What the meaning of inverse initial permutation means? It is also simply changing the bits position. This is also simply changing the bits position, and after that it will produce the 64 bits of output. And what is the output will be coming out from inverse initial position? That is our cipher text. It is our cipher text. Okay, this is the DS algorithm. This is the structure of the DS algorithm, plain text to cipher text. Okay, here first initially the data will goes to the initial permutation, and later it goes for the round operations up to 16 rounds. The data will be applied, the output data will be applied to 32-bit swap function, 32-bit swapping operation. After that it will goes to the inverse initial permutation, and finally we are getting the cipher text. And what will be happen at right side? At the right side we are taking the initial key size is 64 bits. So this is the 64 bit key size, and the key will be applied to permutation choice 1. This is the permutation choice 1. And what is the operation here? The permutation choice 1 converts 64 bits into 56 bits. 54 bits into 56 bits. Okay, it reduces the 64 bits into 56 bits. This 56 bits went to the left to circular shift operation. 56 bits will be applied to the into the left circular operation. Here after shifting the bits, again it produces the 56 bits. These 56 bits again goes to permutation choice 2. This is the permutation choice 1. This is the permutation choice 2. Here again 56 bits will be converted as 48 bits. These 48 bits are the K1 round key. These 48 bits are the first round key function, first round key. This is the 48 bits are the first round key. And similarly, after performing left circular operation, what is the 56 will be go to the permutation choice 2. Again the bits will be coming out from 48 bits. These are the round 2 key. Like this, round 1 choice bit, round 1 first key, round 2 second key, up to 16 rounds. For every time it will returns a 48 bits of key, that is the round key, up to 16 rounds. This is the similar process. Up to 16 rounds is the similar process. After that, after 16 rounds, the output of the 16th round is 64 bits with help of the 48 key. The 32 bits will be swap operation after inverse initial position permutation 64 bits. What is the output of the inverse initial permutation output? That is the 64 bits is the ciphertext. That is the ciphertext. This is about the DS algorithm. But we should know what will be happened in initial permutation, and what is the 32-bit swap operation, what is the inverse initial permutation, what is the permutation choice. We should know. In exam also we have to explain these blocks, what will be happening inside the block, and how the key is reducing from 64 bits to 56 bits and 56 bits to 48. Okay, we will discuss. Okay, first one, first if you see what is meaning of initial permutation. In initial permutation means it is simply changing the bits position. Okay, see here, this is the bits. I am writing here 8 into 8 structure, 8 into 8, 1 to 8 and 9 to 16, and like that if you write 57 to 64. This is the initial plain text bits, plain text box. By performing initial permutation, the bits will be changes the position like this. How means the first row data will be written at right side. Okay, the first row data I have to write the right side. In that also, first to top side we have to write even numbers from top side to bottom. Top to bottom I have to write the first even numbers, then odd numbers. Here in this first line, what are the even numbers? 2, 4, 6, 8. I am writing here 2, 4, 6, 8. And what is the odd numbers? Odd numbers are 1, 3, 5, 7. I am bottom side I am writing 1, 3, 5, 7. And second line 9 to 16. In that also even numbers are 10, 12, 14, 16, and odd numbers are 9, 11, 13, 15. Like that we have to write all the 8 rows. Okay, after writing all the 8 rows, this is the initial permutation values. Initial permutation values are the these 64 bits. This is the plain text message. After performing initial permutation, this is the 64 bits. And what is the inverse initial permutation? What is the inverse initial permutation means? These are the 64 bits will be again change their position as again change their position. Okay, how it will be changes? Inverse initial permutation, the values are the top side value, the first row data. What is the first row data? We have to write from bottom to top. What is the bottom value here? The first row data is 1 to 8. But I has to write bottom to top means this is the first two I have to write. I have to write this one. 1, 2, 3, 4, 5, 1 to 8. And after that we have to leave one column space and the second row in data from bottom to top 9 to 16, and they have to leave one space, and 17 to 24 again I have to leave one column space, and 25 to 32. And after completion of 4 rows, 4 columns, again we have to write from fifth one as the left side, again the 33 to 40, and after that 41, and after that there is a space we are leaving for a column space that I have to use 41 to 48, then 49 to 56, and 57 to 64. This is the output of the inverse initial permutation. And next, we will see what is the round operation. In each round, what will be happening? That will be we see in single round operation. In single round, the total input size is 64 bits into 2 halves. Okay, the plain text data is divided into left side bit and 32, right side bits 32. In that one, the left side will be simply will be there, and the right side 32 bits will apply. First one is expansion permutation table. What is the meaning of expansion? The 32 bits, what is the right side 32 bits will be expanded as 48 bits. The expansion means expanding bit size, bits length. Okay, the 32 bits will be expanded to 48 bits. After this is the input, is the output. After 48 bits, this 48 bits will be applied to XOR operation. This 48 bits will be expanded to XOR operation. In the key round 1, we will get the key. We already explained this part. Okay, currently what we are explaining here? What is the operation will be happening in this round? That is really I am explaining here. Okay, this is the round operation. Okay, here this is the 48 bits coming from the key. Okay, and after XOR operation, again we are getting the 48 bits of the output. This output will be applied to substitution choice or S box. This is the substitution choice or S box. And here, what is the substitution choice or S box means? This is the operation will be performed. The key size will be reduced from 48 bits to 32 bits. The key size will be reduced from 48 to 32 bits. After performing S box operation, before that 48 bits will be reduced to 32 bits, and after that it will be went to the permutation block. What is the meaning of permutation block? Permutation block means what? Permutation block is nothing but again the bits will be changed their positions. Again the bits will be changed to their position, and the 32 bits will be goes to the XOR operation. This XOR operation, after XOR operation, it will performed with help of the left side bits. XOR operation will be performed with help of the left side bit and right side bit. With XOR operation we are getting the right side bit, and after that the right side bit will be swapped with the left side, and left side will be become as the right side. Okay, this will be performed in a single round operation. The same diagram will be repeated in DS algorithm totally 16 times. Okay, clear? Okay, next one. What is the expansion table? What is the operation will be happening in the expansion table? Okay, this is the expansion table diagram. In this one, in this expansion table, the input 32 bits are converted into 48 bits. Input 32 bits are converted into 48 bits. Okay, here we have to take 8 blocks. 32 bit means 8 into 4. How many words are 32 bits? So I am taking here 8 blocks. Each block contains 4 cells. This is the first one, second one, third one, up to 8 bits, 8 blocks. Each block contains the 4 cells, and how it will be converted as a 48 bits. Okay, see here. Then same like that, 8 into 6 equals to 48. 8 into 6 equals to 48. So here, again I am taking 8 blocks with 6 cells. 1, 2, 3, 4, 5. 1, 2, up to 8 blocks. Up to 8 blocks with 6 cells. Okay, here the first block, first cell will goes to the second block, first block of the second cell. Like this value will be expanded here. And what about this last one? This last one, after next one of the first block, and the end of the first one will be expanded to next one. Okay, like this it will be expands the size from 32 bits to 64 bits. And what about the first one? It will be expanded to the last size of the last bit, last cell of the last block of the last cell, and last cell this will be like this. Okay, like this the 32 bits will be converted as 48 bits. The 32 bits will be converted as 48 bits. Okay, this is the diagram. In really how it will be expanded means this is the numbers. Okay, here the 32 bits. Okay, here first cell, second block, third block, 4, 5, 6, 7, 8 blocks. Each block contains 4 bits. Okay, how to expand it means here the first two words, first column we have to write. First column we have to write means the first element we have to write the last, remaining as usual from top to bottom. Okay, first we written here the first one, remaining as usual as from top to bottom, 5, 9, 13, 17 like that. And what is the last column? These values you have to write. The last element has to have to write the first, remaining as same as top to bottom, 4, 8, 12 like that. Like this, after expansion table, 32 bits will be expanded as 48 bits, up as a 48 bits. Okay, see here, S box operation, the 48 bits converted to 32 bit. Again, here in 48 bits. Okay, this is about the expansion table. How the bits will be reduced, and from 48 to 32 bits means, okay, see here, 8 blocks means 6 bits. It means 48. Those are called as S1, S2, S3 up to S7, S8. And S box represented what? S box represented matrix format. Matrix means what? Rows and column. 48 bits equals to that 48 bits will be converted as 32 bits. That means 8 into 6 converted as 8 into 4. Totally 6 bits input and 4 bits output. Okay, see here. Here I am taking the bits are 6, 1, 2, 6. Okay, in that one, the first one and last one will be index for the lines. In the first bit and last bit are the index for the lines, and remaining 4 bits contains 16 possibles. 16 possibles. So here I am taking 0 to 16 possibles means what? 0 to 16. So 0 to 15, and this is the columns. Okay, with 2 bits. Okay, if it is a 2 bits means 0 and how many possibilities we have? 4 possibilities. So I have to take 4. 0, 1, 2, 3, 4. 0, 1, 2, 3 and 0 to 15. Okay. Here for time this diagram I am expanding here 0 to 15 and 0, 1, 2, 3. Again, here we can write any values in this 0 to 15. From 0 to 15 values, you can write any random. You can declare any random values. And suppose after declaring all the 4 lines, suppose if you take any 6 bits, how it will be converted as 4 bits. Okay, for example, I am taking here, this is the 6 bits value. This is the 6 bit. What is the 6 bit value? 0, 1, 1, 0, 1, 1. Okay, in that one, what is the first one and last one? The first one and last one will be what? Considered as the 0, 1. The first one and last one become as the 0, 1. That means first line. That means first line. Okay, first line means we have to consider the first line. What is the first line here? This is the first line. And then what is the next bits? 1101. If you write according to 8421, according to 8421, 1101, it means 8 plus 4 plus 0 plus 1. What is the value? 13. It means 13th cell, 13th column, 0th line and 13th column. What is the 13th column is 5. So what is the value of, what is the value here? 0101 value is 5. Is 5. Again, if you convert this 5 as in according to 8421, 0101. So 5 will be converted as 0101. So what is the input value? Input is 0101. 011 is converted as 0101. This is the Xbox operation. In the Xbox operation, the 48 bits will be converted as 32 bits. Okay, this is about the DS algorithm. If you have any doubts, please ask me in comment section. And also like our videos and subscribe our YouTube channel. Okay, this is the DS algorithm. Left side we have to take the plain text and right side we have to take the ciphertext. Sorry, right side we have to take the key size and how it will be performed. What are the operations are performed? Okay, is seen in this video. Okay, thank you everyone. AES algorithm, advanced encryption standard algorithm. Okay, if you see in last class we discussed about DES algorithm. What is DES algorithm? Data encryption standard algorithm. Okay, it is replacement of, AES is the replacement of DES algorithm. Okay, see here, it is a symmetric key block cipher. What is the meaning of symmetric key? First of all, a symmetric key is nothing but here a single key used for encryption as well as decryption. Okay, the same key used for encryption as well as decryption, those are called symmetric key. Okay, and what about block cipher? The plain text data is divided into number of blocks, and as well as the same same size of the bits will be created as the ciphertext. That is called block cipher. Okay, next, AES algorithm was established in the year of 2001 by National Institute of Standard and Technology, and it is a AES algorithm contains totally 128 size. It contains fixed block size. The size is 128 bits, and it will take totally 10 rounds of round operations. It will perform totally 10 rounds of the round operation. And what about DES? In DES we are performing 16 rounds. Here we are performing 10 rounds, and AES is the replacement of DES algorithm. AES is the replacement of the DES algorithm, and in AES key size will be changed based on the plain text, and the number of the rounds are also depends on the key size. Okay, in DES algorithm it is the size is 64 bits, key size also 64 bits. In that we will convert 56 bits as a sub keys. Again in the 56 also we will use the 48 bits for the round operation. But in AES algorithm the plain text size is 128 bits, and the key size will be depends on your requirement, and the number of rounds will be depends on the key size. Suppose if you take 128 bits key size, then the rounds are 10, and suppose the rounds are 10. Suppose if you take 192 bits, the rounds are 12. Suppose if you take that 256 bits, the key size means that totally it will perform 14 rounds operation. Okay, clear? Next, here the plain text represents 4 into 4 column measure matrix. The main thing is in AES algorithm, the AES algorithm represents in the form of the 4 into 4 matrix. 4 into 4 matrix. Here the key size is 128 bits, which is passed in terms of the words. Generally the 128 bits will called as the words. The form is words. Okay, here the key size is 128 bits will be passed in terms of the words. It will be 128 bits will be considered as in the form of the words. Here, what is the word? Here, one word equals to 32 bits. One word equals to 32 bits. It means if we are taking the key size is 128 bits, then how many words? The 128 bits will be converted as 4 words or 16 bytes. 4 words are 16 bytes. The number of subkeys are equals to 44. We used in each subkey size is 32. 32 bits are one word or 4 bytes. The total number of subkeys we are using means 44. Okay, we are using these are the round operation. Next, see in each round we are using 4 subkeys. Those are the 4 into 32. Those are the 4 into 32. That means what? 4 into 32 means 128 bits. Okay, to perform in single round operation, we have to use the 4 words or 16 bytes. 4 words are 16 bytes. Okay, see here, this is the AES algorithm block diagram. This is the AES algorithm of the block diagram. In this one, I will explain clearly. Don't confuse here. Here, left side, we will take plain text message. Right side, we will take the key size. Right side, we will take the key size. Okay. Here, first step in 128 bits plain text message will be converted into 4 into 4 matrix. I already explained that where the plain text will be converted into 4 into 4 matrix state format, that is the input. And after that, the 4 into 4 matrix will be applied to initial transformation. What is the meaning of initial transformation? We already seen in DS algorithm. Here, initial transformation means simply the changes of the bits position. Simply bits positions will be changed. That is called initial transformations. Next, and after the output of the initial transformation, this is the again we will get the 4 into 4 matrix. Okay, here to perform initial transformation, we will get round key 0. Round key 0 from where? From key. Okay, see here. From right side, we are taking the key. Right side, we are taking the key, and the key is also converted into 4 into 4 state format. 4 into 4 state format, and then output will be went to the key expansion. Okay, here there is a block key expansion block. Okay, here key expansion block means it will generate the sub keys. The key expansion block will be generates the sub keys for each round operation. Here at the time of the initial transformations, the key generator, the key expansion will be generates round key 0. The round key 0 used for is the round key 0. It is also 4 into 4, and by using this round key 0 operation, the initial transformation will be performed with plain text, and the result of this one again into 4 into 4, that will goes to round 1 operation, that will apply to the round 1 operation. And at the time of round 1 operation, again this key expansion will generate a key 1, that is also that will be implemented, sorry, that will be applied to the round 1 operation with help of the key and previous output data. Both will be performed round 1 operation. After round 1 operation, the result will be goes to the round 2 operation. Again the key expansion will be generated the second key 2. With help of the key 2, we will perform the round 2 operation, and up to like this, totally based on the key size, several rounds of operation will be performed. At end of the last round, we will get cipher text. At the end of the last round, we will get cipher text. Okay, these are about the AES algorithm. Here the main important is in round 1 and round n minus 1, we will perform 4 transformations. Okay, in each round we will perform 4 transformations. In round 1 to up to n minus 1. Up to n minus 1 means last before round, we will perform 4 transformations. And what about in round n? It means in the last round, we will perform only 3 transformations. Okay, what is the operations will be happening in the rounds? We will see in this video only. Okay, this is about the DAES algorithm. Okay, see here, and what are the transformations we are performing? Okay, see, these are the in round operations. What is the round operation will be happen inside the round operations? Okay, round operations. In round operations, we will perform 4 transformations. What are the 4 transformations we are performing? Here, the first transformation is substitute the keys. Second one is shift to rows. Third one is add row matrix, and fourth one is the add column matrix. These are the four transformations we will perform in round operations. But the first one will be performed if you take the 10, if you take 128 plain text means, and the key size also, we are performing 10 rounds, and second one also performed 10 rounds, and third one will perform only 9 rounds, and last one also perform 10 rounds. It means first one, second operation, and fourth operation will be performed each and every round, and n minus 1, sorry, in the last round, the third one will be not performed. Okay, what is the substitute bytes? Okay, what is the first transformation? Substitute byte. Here, where the one byte is replaced with another byte. Okay, for example, see here, this is the 4 into 4 matrix. Okay, assume this is the 4 into 4. Here, this is the bit. Okay, assume here we are writing S00, S01, S02, S00. Okay, like that we are taking here. If what is meaning of substitute of the bytes means one byte, one bit, one byte replaced with another byte. Okay, here suppose here the data is 45. Assume here the data is 35. Then if you are performing substitute bits, the 35 will be replaced with some other bit. For example, like 35, sorry, 45 or some random number will be updated instead of 35. That is called substitute of the bits. Okay. Substitute of the bits in round 1 we are performing 4 transformations. For convention we use predefined S boxes. Here for example if the data is 35, after substitution we will get the 45. After substitution we will get the 45. Okay, the second transformation is shift to row transformation. What is the meaning of shift to row transformation? Shift to row transformation is nothing but one position of the row will be shifted to left side. One row position will be shifted to left side. For example, shift to row operation we apply after substituted matrix. Simply shift to row of the table. Row 0 to no change. Here row 0 is no change. For example, it is the basic. It is the initial data. It is the shifted row. Okay, here shift to row. Yes, there is a row 0 is no change. So it is the as is. And what about here? In row 1, the first data is row 10, and what about here row 11? Okay, after shifting this one, okay, that means the left side first to all the row first cells will be shifted to left side. Means this is the left side means what happened? It again will come to the right side of this one. Okay, same here also. S10 is shifted means it goes to right side one, and here also S20 also. Here in first row we are shifting one circular shift, here two circular shifts, and here three circular shifts. Okay, here 10 is shifting means what? Circular means again that we have to move to right side, and here two circular shifts. So S20, S21 is shifted to right side. So S222 came first one, S223, and here S220, S221. Okay, here three circular shifts means the first three cells will be shifted. So S33 is coming first side, and remaining 30, 31, 32. Okay, this is about the shift to row operation. This is the second transformation. And what about the third? Okay, what about the third transformations? In third transformation is nothing but add column matrix. Here each and every column is treated as the separately. Okay, don't confuse here. In this one, each and every column will be treated as the separately. That is, we are performing operations on each column identically. Okay, it means in each and every column we have to perform the operations separately. Okay, for example, here taking matrix values. For these are the random values I am considering. These are the matrix values, random values. Okay, only 3 values. Okay, if it is the first row, there is no change. Okay, in first one there is no change. And what about the byte? In the second time, the bytes will be replaced with corresponding values. Okay, here first one is the no change, and what about the second value will be changes according to corresponding values. If the byte is multiplied with 1, then the column position will be not changed. Okay, here the entire the matrix, if you multiply with 1, there is no change. There is no change. And if the byte is multiplied with 2, if this data is multiplied with 2, the column position will be shifted left side one value. The entire, if you take the first column is no change. Okay, if you multiply with 2, one value will be left shifted to left circular operation. Again means this will be come to the this side. And if the shifted by 2, if multiplied with 2, that means the column positions will be shifted left side by 1. Okay, and if we multiplied with 2, 3, the column position will be shifted left side 1 and perform XOR operation with left shifted column and before shift key, after shift key for performing XOR operation. Okay, this is called add column matrix. This is about the add column matrix. And fourth transformation is add round key. What is the meaning of add round key? At each and every round, we have to add round key value. That means from key expansion, we will get a key that will be added at the plain text. Okay, in the main. Okay, see here, this is the plain text message. Here we are getting the key. These both will be perform XOR operation. And what is the data we are getting? That is the add round key output. Okay, text and key you are performing XOR operation. And after that we are getting the add rounded key plain text message. This key with applied to each and every round. Okay, here the main thing is, in round operations we will perform 4 operations. The first one is substitute bytes, second one is the shift rows, then third one is the add row matrix, fourth one is the add column matrix. Here first two, we have to apply 1 to n-1 rounds are, we have to apply 4 transformations. Okay, and what about the last transformation? In last one we will apply only substitute bytes, substitute rows, add row matrix key only. Okay, here what is the key expansion? Key expansion is nothing but how the subkey are generated in round operation. Okay, this is very important. Okay, here key size is 128 bits. Key also represents state format. Okay, here. Okay, assume here this is the key. This is the main important diagram. Here the key is the divided into K16, 4 into 4 matrix is the key. Now how it will be keys will be generated. Here in the entire column we are writing W1, W2, W3, W4, and after that if you want to expand more number of keys, okay, here we have to perform XOR operation. Here we have to perform W1 with, we have to take a special variable Z1. After Z1, with Z1, if you are perform if you perform XOR operation, we will get the W5. Okay, we will get the W5. W5 means what? It is some additional next key. And to get the next key, I have to perform W2 with XOR with W5. We have to take W2 and XOR operation with W5. Then we will generate the W6. And again, if you want to generate W7, you have to take W6 XOR operation with W3. Then we will generate the W7. To generate W8, we have to take W4 XOR operation with W7. We will generate the W8. Again, if you want to generate W9, again we have to perform W9 XOR operation with W5. We will generate the. Again, we have to take one more variable. We have to take W9. We will get the W9. Again, if you want to generate XOR operation with W9, we will generate the W10. Okay, like this. W11, if you want to generate, W11 means XOR operation with W10 with W7. Okay, then we will generate the W11. Okay, like this procedure will be continuous up to how many number of keys you want. Okay. To say simply the block diagram of AES is, this is the simply block diagram. Here the plain text will apply the round key operation. Inside the round we are perform the 4 transformations. These 4 will be performed in up to n-1, and the last round will apply only these 3 operations. In last round will apply only these 3 round operations. Okay, clear? This is about the AES algorithm. If you have any doubts, please ask me in comment section. Also share our videos with your friends. Okay, thank you. Okay, thank you everyone. Please subscribe my YouTube channel. Hello everyone, welcome to my YouTube channel Concept Clear. In today's class, we will discuss about blowfish algorithm in the subject of cryptography network security. What is blowfish algorithm? Blowfish algorithm is replacement of idea algorithm and DES algorithm. Okay, the first one is it is it is symmetric key algorithm. Symmetric key algorithm, and it is block cipher algorithm. Block cipher algorithm. We know what is symmetric key, what is block cipher. For every topic I am explaining. Okay. Next, blowfish is replacement of. Okay, what is the drawbacks in DS algorithm and idea algorithm? That those problems are overcome in blowfish algorithm. Okay, this is the replacement of these two algorithms. Okay, clear? Next, blowfish follows fetal structure. Blowfish follows fetal structure. I already explained what is the fetal structure in previous topics. Fetal structure. It is a follows the fetal structure. What is the fetal structure? That plain text will be divided into a number of parts. Left side part and right side part. After performing operations, both will be swapped. Okay, that is the fetal structure. Okay, clear? Next, the input plain text is 64 bits and key size is, here there is no fixed key size, it is the variable length, it is the variable length. That means 32 to 448 bits according to your requirement. You can consider 32 to 448 variable size. Okay, and default size is default key size. If you are not taking any key size, means default key size is 128 bits. Okay, it is the 128 bit is the default size. And number of rounds, are 16. Here 16 rounds of operation will be performed. And what is the advantages? The advantages means it is very fast, take less memory, and it is more secure. Why? Because if if the attacker knows he used blowfish algorithm, even though he can't he can't decode our messages. Why? Because he can't know what is the key size. Key size is variable. It is the advantage. Okay, your message is hacked by hackers also. You know you are using blowfish algorithm, even though he can't able to decode your message. Why? Because the size is don't know. Okay, we are using from 32 4 to 445, 448 bits. So he can't guess the exact size of the key. Okay, clear? Here, blowfish algorithm contains two parts. Okay, what is the two parts means? The first one is encryption. Sorry, first one is key generation, and second one is data encryption. Data encryption. We will see one by one. What is the data key generation and the data encryption? Okay. Next, first we will see what is the first one is key generation. What is the meaning of key generation? Key generation is nothing but what? Key has to generate to perform the encryption algorithm. It follows some steps. Here the step one is, what is the step one? Key are stored in array. First the key is stored in array. Okay, what is the keys we have? K1, K2 and up to Kn. Up to Kn. Here 1 key equals to 32 bits. 1 key equals to 32 bits. Don't confuse here. 1 key equals to 32 bits. So what is the K1 equals to 32 bits. So range is what? Range is 32 to 448 bits. 32 to 448 bits. If you divided 32 bits, so the length of the each block is 32 bits. So 32 into 14, 32 into 14, then we will get the 448 bits. Okay, we can take between the range of 32 to 448 bits. This is the first step. Okay, step 1. What is the second step? In second step, the original message is divided into subparts. Okay, totally 18 subparts will be divided. Okay, here original message, original key divided into 18 subparts like P1, P2, P3 up to P18. Okay, original key divided in as 18 subkeys. Okay, keys at the same time along with the key. Okay, in third step, the original key is divided into 18 subparts. 18 subparts are 18 words. Okay, along with the key, there is a S boxes, substitution boxes also divided. Okay, in third step, along with the keys, S boxes also divided as 4 boxes. Okay, what is the S1, S1, S2, S3, S4 boxes will be divided. What is the range here? S0 to S1 up to 255 range. So X box value is what? X box value is 256. X boxes. Okay, keys. It is also divided into different X boxes here along with original keys. X box is also divided into several sub keys, sub boxes. Next, what is the fourth step? Initialize each element of the P array and S boxes with hexadecimal. Okay, you have to initialize P array and X boxes with hexadecimal values. That nothing but we have to perform XOR operation. Nothing but we have to perform XOR operation between P and K, P1 and K. Okay, example, you have to perform the XOR operation between. Okay, how many XOR operations? How many times totally? 18 times we have to perform. Okay, next, what is the next step? In next step, we have to perform XOR operation. Step 5, we perform the XOR operation. P1 equals to P1 XOR K1. P1 XOR K1. Here, you are performing P1 with XOR operation with K1. Again, you will perform a new P1. It is the new P1. Like that, you have to perform P2 with P2 XOR of K2. Okay, like this, you have to perform totally P14 equals to P14 XOR of K14. Here we seen that how many, if you divided 448 by 32, we will get the 14. So what is the keys? We will get the keys are the only 14 keys. So the key values are what? The key values are 1, 2, 3 up to K14. But how many rounds, how many P's we have? Here the P's are divided into P18. Keys are the K4. Here P's are the divided into 18. Keys are the 14. But here for performing XOR operation, here P1 up to P14, all the keys are completed. Then what happens? Then we have to use again from K1, P15 equals to P15 XOR operation K1. Like that we have to perform up to P18 equals to P18 XOR operation with PK4. Okay, these are the bits will be repeated, and after fifth step and sixth step is after XOR operation we need to take 64-bit plain text. We need to take 64-bit plain text. Initially all bits are 0. Initially all bits are 0. Sub key is generated. Okay, that is the first part. And second part is what? The second part is data encryption. Data encryption. We will see one block diagram for data encryption. How it will be encrypted the data. Okay, here what is the plain text? The plain text size is 64 bits. The plain text size is 64 bits. The plain text is divided into two parts. Left side P equals to 18. It is the left part, and over this is the right part. This is the right side part. Left side part and right side part. Here 64 bits will be divided with the what? 32 bits. These also 32 bits. Here the left side part we have to perform XOR operation with first P1 here like this, and here we are taking XOR function with what is the function F, and here we are taking 32 bits, right? Again we are performing XOR operation that will be generated this side, and here we are performing left side XOR operation function and right side XOR operation function. After these two results will be swapped left side to right side to left side. Again here we are getting XOR operation with what? P2, and here also to function F, and same diagram will be repeated up to 18 times up to P18. After P18 this left side part and right side part, after 18 times up to P18 rounds, same operation will be repeated. After 18 rounds, your left side part and right side part will be added to generate cipher text message. To generate the cipher text is generated. What is the size of cipher text? Is also 64 bits. Why? Because the plain text is 64 bits. The cipher text also 64 bits. Okay, clear? This is about the data encryption. This is the data encryption algorithm. And what is the function operation will be performed inside the function operation? Actually, what will be happen? We will see here. In function operation, we will see the what is the function operation. The function operation, the function is divided into four parts. Okay, the function operation is divided into four S boxes. Function is divided as 4 S boxes. Okay, each S box contains 8 bits. Each S box contains 8 bits. So here 32 bit is divided into 4 into 8. That means 32 bits. Okay, 4 into bit 8, 32 bits. Okay, here it is divided into 4 parts. 1, 2, 3, 4. Okay, here the first one is 8 bits. Second one also 8 bits. 8 bits, 4 bits. Okay, and the first one is the S box 1, S box 2, S box 3, S box 4. Okay, here what is the function operation? Here in this data encryption time, what is the operation will be performed in this function block? We are seeing here. Here in the function operation, here in the first X box will be performed XOR operation with S box 2. These two will be performed XOR operation. The result of these two, the output of these two will perform again XOR operation with Xbox 3, and this output is again performed XOR operation with Xbox 4. This is the 32 bit of particular function, the 32-bit output function. The first to 32 bits is divided into four parts. We need to, these first to 32 bits will be divided into four parts. We need to perform XOR operation with Xbox 1 with Xbox 2, and output will go to again XOR operation with Xbox 3. After Xbox 4, we will get 32-bit output Y. Okay, that means Y is the output of function F. Similarly this operation will be repeated up to 18 rounds, okay. And after 18 rounds, what is the data we are getting, what is the data we are adding from left side and right side data is called ciphertext. Okay, clear? This is about the blobfish algorithm. It is a different algorithm by comparing AES algorithm, DS algorithm and ID algorithm. Here the key size is 32 bits to 448 bits. That is the variable size. Even if you are using the blowfish algorithm, the attacker can't encrypt your data as original message. Why? Because the key is the variable size. Even he knows that you are using blowfish algorithm also, he can't decode our data. So it is the more secure. It is providing the more secure. Okay. So thank you everyone. If you have any doubts, ask me in the comment section. Also subscribe our YouTube channel. Many people are watching our videos without subscription. Okay, please subscribe our YouTube channel. Thank you everyone.
నా ఛానల్ పేరు
What are the three parameters means? It contains three parameters. The input data W equals to word size. The word size in bits 16 or 32 or 64. Okay, here data equals to 2 words. Data equals to 2 words, and number of rounds. R equals to number of rounds is 0 to 255, depends on, and B, number of bytes equals to number of bytes size is 0 to 255, and the nominal version of RC5 is about the customized. It means the customized parameters. The general normal RC5 contains 32, 12 and 16. That means 32 means what? 32 bit words encrypts 34 bit encrypts 64 bit data blocks. Okay, it means 32 bits means what? It encrypts the 64 bits data blocks. Why? Because data equals to 2 words. So here 32 words means what? 64 bit data blocks. It using 12 rounds. It uses 12 rounds operation with 16 bytes. 16 bytes means what? 128 bits. Secret key is used. It means 16 into 18, 128 bits. Okay. Generally, the customized versions are it will be varies between 16, 32, 64. Okay, and depends on the rounds also varies, and the number of bytes also varies. Okay, generally, normally RC5 contains 32, 12, 16. Based on the suppose if you take 32 bits words, it will encrypt 64 data blocks, and it will take 12 rounds of operation, and with 16 bits, 16 bytes means 128 bits. So what is the secret key? Secret key is 16 into 8, 128 bits. Okay, it will take 128 bits secret key, and mainly the RC5 contains 3 components. RC5 components. We will see what is the RC5 components. It contains 3 components. The first one is key expansion. and second one is encryption and decryption, encryption or decryption, and last one is encryption, sorry, second one is encryption algorithm, don't mind, second one is encryption algorithm, and third one is decryption algorithm, decryption algorithm. Here we will see one by one. Okay, we will see one by one. Here, what is RC5 first? RC5 is a symmetric block cipher. What is the meaning of symmetric block cipher? A single key. Okay, RC5 is a what? It is a symmetric block cipher. It means what? Single key used for encryption and decryption. Here, the plain text and cipher text are fixed length sequence of bits. Okay, here plain text and cipher text fixed size fixed size fixed size length bit in sequence. Okay, here we will see one diagram for what is secret key. Okay, see here is the diagram for secret key. Here the secret key k belongs to key expansion algorithm. What do you mean of key expansion algorithm? Here it will generate 128 bits key, generates 128 bit multiple keys, 128 bit multiple keys. Okay, after expansion algorithm it will generate the multiple 128 bits keys. Okay, here expanded key is S. Okay, then here if you are performing encryption, you are performing encryption, we will the performing encryption, it will consider plain text as the input is plain text, and after performing encryption algorithm we will get the cipher text is output. Okay, and same time, okay, same as if you are performing decryption also, the expanded key S went to decryption algorithm. Here input is cipher text, we will consider as input as a cipher text, and after performing decryption algorithm we will get the plain text as the output. Okay, this is about the block diagram of RC5. This is the block diagram of RC5. First, what is the thing? We have to take secret key, we have to apply the expansion algorithm, and after expansion key went to the encryption algorithm to convert plain text into cipher text, and same expansion key went to decryption algorithm to convert the cipher text into plain text as the output. Okay, we will see what is the key expansion algorithm. Okay, in key expansion algorithm, in key expansion algorithm in RC5, the plain text message is divided into two blocks, and A and B with 32 bits. Okay, these are 64 bits. Then the divided into 32 bits and 32 bits. Then the two sub keys are generated, S0 and S1. S0 and S1. These two sub keys are added into A respectively, and C and D also, furtherly C and D also. Then it will goes to round 1 operation. This is the round 1 operation. Round 1 operation, the plain text is true words. Okay, see here the diagram. The plain text is divided into two parts of left side part and right side part, A and B. Here left side it will take S of 0 sub key, right side will take the S of 1 sub key. And after that, here with the help of the S of 0, we will perform bitwise operation. This symbol is nothing but bitwise operation left side with help of the bitwise XOR operation. It is bitwise XOR operation. Okay, and it is also bitwise XOR operation. After bitwise XOR operation, what is the result we are getting? Again, that result will perform left shift operation with help of the right side, with help of the REO, with help of the right side data. Okay, right side data. Next, and after left shift operation, the data again will be added, will added the S of 2 key, S of 2, respectively S of 2 key. And what about right side? In right side, here first the 32 bit will be added with 2b S of 1. Here we'll perform XOR operation, bitwise XOR operation. It is the bitwise XOR operation, and the result to perform bitwise operation, we will consider here the left side round one result. The left side round one result will be considered as the input to B side. Here we will perform XOR operation. The result again goes to shift operation. Here again in the shift operation, we will consider shift previously bitwise XOR operation data and the left side final ciphertext as the input. Will perform shift to left circular operation. Left circular operation. This is the symbol is nothing but left shift circular operation, and after that we will get the ciphertext. Here we will get the round one ciphertext. Again here we will add next key S of 3 here, and we will repeat this procedure up to number of rounds, up to n number of rounds. The rounds will be depends on the key. Rounds will be depends on the key. This is about the encryption algorithm. This is the first S of 0 to adding S of 2. This is the round one operation. This operation will be performed multiple times. Okay, see here what will happen in round one round operation. The plain text అనేది రెండు పార్ట్లుగా రెండు భాగాలుగా విడిపోతుంది. లెఫ్ట్ సైడ్ 32, రైట్ సైడ్ 32 ఉంటుంది. లెఫ్ట్ సైడ్ will add S of sub key, will name as the A. Left side part is called A, that will be added S of 0 sub key. Right side part will be added S of 1 sub key, that is called B. And after that we will perform bitwise XOR operation left side. Okay, with help of the right side, which is about the right side data, will consider left side, will perform the bitwise XOR operation. And after result of the XOR operation, the data will be performed shift left operation with help of the data will be performed shift to left operation with help of the again right side data. Okay, after result of the shift right operation, we will add next sub key S of 2. We will add next sub key S of 2. The result data will be goes for right side XOR operation. The result of this adding sub key, the data will be go for XOR operation of right side. After result of the XOR operation, again we will perform shift operation with considering right left side data, and this procedure will be repeats up to multiple rounds for encryption. Okay, and finally after n number of rounds, we will get left side will get ciphertext data. This is the encryption diagram. This is the encryption diagram for round one up to n number of rounds. Final round we will get the ciphertext. We will get ciphertext. If you repeat the same procedure in reverse order, we will get plain text. This is the top to bottom. See here, this plain text to ciphertext. And what about here? Here it is ciphertext to plain text in reverse mode. Same operations we will perform in decryption algorithm. This is about the RC for encryption. Okay, here generally what will happen in encryption algorithm? In encryption, what happened means it is not a classical Fisher structure. Okay, RC4 encryption is not a classical Fisher structure. Why? Because here in classical Fisher structure, for every round the data will be swapped, but here there is no swapping, so it is not a classical Fisher structure. Here plain text is assumed reside in two words bit resides in A and B. The plain text is resides in A and B. Okay, here left LEI and REI is called left side and right side of. Okay, here it is LEI and it is the REI. What is meaning of LEI and REI? Means left side and right side data. Okay, after round 1 it is completed. The round 1 data will go for right side. We will apply XOR operation, shift operation like this. Okay, it is a substitute using both word and data. Okay, it is a substitution that depends on the key. Okay, here what is the encryption actually here? Input split into two of A and B. Left side data is called L of 0 A plus S of 0. Right side data B plus S of 1. For I equals to 1, so I equals to 1 to R2. We have to perform L of I minus 1 XOR Ri minus 1. It is of shift operation Ri minus 1 plus S of 2 into 1. Okay, and what about right side? Right side equals to, right side we have to perform R of I minus 1 with help of XOR operation Li. Okay, again shift left operation with Li plus S of 2xi plus 1. Okay, in each round the operation equivalent performs to 2 rounds DS algorithm. Here actually here in a single round operation it is equals to, okay, each round operation is equals to 2 times DS operation. It means it is more efficient comparing with DS algorithm. We perform each round is equals to 2 DS rounds. Okay, it means one round contains that is 2 rounds. Okay, here the main features of this one is simplicity, data dependent rotations, the string features. Okay, what is the features here? The features are simplicity and data dependent. Okay, data dependent rotation. Okay, this is about the RC5 algorithm. If you have any doubts, please ask me in comment section. Okay, this is about the encryption diagram and this is the decryption diagram for RC5 algorithm. RC5 means what? RC5 is nothing but reversed cipher 5. Okay, it was developed by Ronald Rivest. Okay, if you have any doubts, please ask me in comment section. Thank you everyone. Please subscribe our YouTube channel.
నా ఛానల్ పేరు గుర్తుందిగా, ప్లీజ్ లైక్ షేర్ అండ్ సబ్స్క్రైబ్. ఏంటి
Cryptography network security. First of all, what is idea algorithm? Idea algorithm is nothing but it is a block cipher algorithm. Idea is block cipher algorithm. We know what is meaning of block cipher. The plain text is divided into number of blocks and the same size of the ciphertext will be created in block ciphers. That is called block cipher algorithm. And it is a semantic key cryptography. Semantic key cryptography. What is meaning of semantic key? Semantic is nothing but a single key used for encryption and decryption. Single key used for encryption and decryption. That is called semantic key cryptography. And idea algorithm follows fetal structure cipher. Okay, idea algorithm follows crystal cipher structure. What is the meaning of crystal cipher structure? The plain text is divided into number of parts. Perform the operations on blocks left. Sorry, the plain text is divided into left side part and right side part. Here, the left side, the plain text is divided into left side part and right side part. Perform operations, and after that, these both will be swapped to left side data and right side data. Again, we are performing same operation repeatedly. This is called crystal structure. This is the plain text. Okay, left side data, right side data. This is the cipher structure, and the size of the plain text is 128 bits. 128 bits. These 128 bits are divided into the size of the plain text is 64 bits. These 64 bits will be divided into 4 subparts, like 4 divided into 4 subparts. Okay, 4, 16, 16, 16, like that 4 subparts will be divided. Okay, next, what is the key size? The key size in IDEA algorithm is 128 bits. The key size in algorithm is 128 bits. These 128 bits will be divided into 52 subkeys. These keys are divided into 52 subkeys. The IDEA algorithm contains totally 17 rounds. Okay, it contains IDEA algorithm rounds are 17 rounds. Okay, it is not like previous algorithms like DES and AES and blowfish algorithms. Here it is different. Okay, how it will be works? Okay, how this will be works? Okay, see here the block diagram of IDEA algorithm is, we are taking here a plain text, and what is the plain text size is 64 bits, that will be divided into 4 subparts. Okay, 16, 16, 16, 16, 16, 16. This is the left side part, and this will be applied to round 1 operation, and then round 2 operation, and up to round 17 operation, and after round 17 we will get again 4 subparts, 16 bits, 16 bits, 16 bits, 16 bits. This is the ciphertext. Okay, after 17 rounds we will get the ciphertext. And what about the key? Here the main thing is the key. Here the main thing is the key. Here what is the key size? This was here, the key size is 128 bits. So 128 key is went to key expansion. There is a key expansion. Okay, and several texts in different books they will give different diagrams, but all are the main thing is all diagrams are similar to relative to our algorithm only. Here also key expansion. What is the duty of key expansion? Here in the key will be generated according to rounds. Okay, what I told here, that the key size is 128 bits. 128 bits will be converted as the 52 subkeys. Okay, 52 subkeys means what? K1, K2, K3, K4 up to K52, up to K52. Okay, like this. Here in odd numbers it will take 4 rounds. Okay, don't confuse here. Odd rounds requires 4 keys, and even rounds required 2 keys. Even round requires 2 keys. Okay, here odd round, if it is the round 1 is the odd round. So how many keys it requires? It requires the 4 keys. And round 2 it is the even number. So It requires the 2 keys. And here, what are the odd rounds here? 1, 3, 5, 7, 9, 11, 13, 17 rounds. Require the 4 keys. And what are the even rounds? Even rounds are the 2, 4, 6, 8, 10, 12, 14, 16 rounds will require the 2 keys. Okay. Okay, here the key expansion will allocate the keys for each round. Okay, if it is the first round, it will send the keys are 4 keys. So why? Because it's the 4 keys means it's the round 1. So it is the odd number. So what are the keys it will be sent? K1, K2, K3, K4. These are the keys used for round 1 operation. Okay, and what about the K2 operation? K2 round 2. In round 2, again it will send only 2 keys. Why? Because it's a round even number. So what are the 2 keys? After first 4 are used. Next one is the K5, K6 keys are used for round 2 operation. If you perform like this up to 17th round, what is the 17th round keys? In 17th round, the keys are the 4 keys. What are the 4 keys you have to use? The last 4 keys are K49, K50, K51, K52. These 4 keys used for round 17. After performing round 17, what is the output you are getting? That is the ciphertext. This is the idea algorithm block diagram. Okay, idea algorithm. This is the idea algorithm block diagram. We will see what will be happen in round operations. In each and round, what will be happen? We will see here. Okay, next round operations. Round operations. In round operations, okay, in previous methods, what is the previous methods? AES algorithm or DS algorithm or blowfish algorithm. In all the rounds of the operations are the same. Okay, in round operation here it is different. Okay, here different round operations in odd rounds and even rounds. Odd rounds are operation is different, even rounds operation is different. First we will see odd rounds. Okay, odd rounds. On odd rounds, how many keys we are using? We are using the 4 keys. So it is the difference. Okay, here input is 4 keys. What are the here input is? Sorry, input is 4 parts and key is 4 keys. So I am taking input parts as a XA, XB, XC, XD. Okay, and key is KA, KB, KC, KD. Okay, I am taking the 4 parts of the input and 4 keys. Okay, what is the operation is performed here? First, XA will be taken as with XA will be generated with help of the KA key. Here these are the keys, these are the inputs. Okay, here XA part perform a special multiplication operation, with KA and generated producer XA. Okay, after plain text is converted into ciphertext also, that is the XA. It is the input to the next round. Okay, next. And KB is what? KB key performed XOR operation with XB generated XC. Okay, and here also XC performed XOR operation, it will generated. Here thus both will be swapped. Here XC produced XB, XB will generated XC. Okay, here it will take the KC key. And what about the last one? XD data will perform a special multiplication operation with key D, and it will produce X D. Okay, this is the about round odd rounds operation. Here, XB and XC are giving keys as a KB and KC, but output will be swap because here XB and XC giving keys as KB and KC, but output will be both will be swap to ensure the security. And what about XA and XD will work as usual, but middle parts will be swap the each other in the round operation. Sorry, in odd round operations and odd round operation when you are using the four keys. And what about even rounds? Okay, we'll see even rounds. In even rounds, the actually here the input is what is the input? Input is four parts. What are the inputs first? XA, XB, XC, XD, and key is two keys. What are the keys? K, E, K, F. Because already we used first four keys, so K, E, K, F is the next keys. Okay, here the total four parts of input and two keys. So we need to combine two inputs as the total two inputs. So we have to add these two and these two. So what is the two inputs? Inputs is 4, keys are 2. Take or consider as two parameters. Two parameters. So what happened? Y in equals to XA modulo operation XB. Z in equals to XC modulo operation XD. So here we are performing XOR operation between X in and XY. Then what we will get? Then we will get the round operation. Okay, here what is the diagram for this one? Here XCA and performing XOR operation with XB. This XOR operation goes Y in. It is applying to the function. Here function we are applying KE key and KF key. And what about right side part? Right side part again we have two inputs. So again here we are also performing Z in. The Z in is combination of XC, XD. And the result of these two, here also we are performing XOR operation. The result of these two will get Y out, Z out. Okay, this is about the even rounds operation. This is about the even rounds operation. Okay, clear. This is about the idea algorithm. This is about the idea algorithm. What is the idea algorithm here? It is the block cipher. It is the symmetric key cryptography. Idea algorithm follows the crystal cipher structure. The plain text size of the idea algorithm is 64 bits. These 64 bits will be divided to 4 parts as a 16, 16, 16, 16, and the key size is 128. Here the 128 keys will be converted as 52 subkeys, 52 subkeys, and here idea algorithm will be performed totally 17 rounds, and each and every round will perform different operations like based on the round even numbers and odd numbers, it will perform the operations are different. Okay, and each round what will happen we will see here. Okay, this is about the idea algorithm. If you have any doubts, please ask me in comment section. Also like our videos and share and subscribe our YouTube channel.
Hello everyone, welcome to my YouTube channel. In today's class, we'll discuss about block cipher operation modes. Before discussing operation modes, first we should know what is a block cipher. What is the block cipher? The block cipher is nothing but plain text is divided into number of blocks. Each block will generate individual cipher text. Okay, here plain text is divided into number of blocks. For example, plain text is A, B, C, D, E, F. Then what is the how it will be divided into number of blocks means A, B, C. Okay, this is the cipher text in block cipher. Okay, why? Because what is the original plain text is A, B, C, D, E, F. Here the cipher text is divided into number of blocks. Okay, here a block can be a size block size can be 40, 56, 64, 128, 256. Okay, according to this the blocks will be divided. Clear? The plain text block size is equals to cipher text block. Okay, what is the original plain text size? The same size will be divided into number of blocks. Okay, here the plain text size it should be equals to cipher text size in block cipher. Okay, here the operation modes in blocks cipher we have several operational modes. Okay, what are the several modes mean? The first one is electronic code book ECB. Okay, the second one is cipher block chaining. Cipher block chaining. And third one is cipher feedback CFB and it is CBC. And fourth one is output feedback OFB. And the last one is counter CTR. Okay, here we will discuss each and every one by one. Okay, what is the first one is electronic code book. Okay, here what is the electronic code book means? Here the plain text is divided into number of blocks and encrypt the plain text with help of the key and we get cipher text and again by using the key you will decrypt the plain text into plain text. You will decrypt the cipher text into plain text. This process will be continued up to first block to up to PN block. First is the up to first block to up to end block. Okay, here this is the first block, second block up to PN block. Okay, here the here first what is the first one happening here? The plain text is divided into number of blocks. Okay, what is the plain text here? Plain text is divided into, suppose the plain text is 128 bit. Assume the plain text size is 128 bits. It is divided into 64, 64. Is the block 1, block 2. So it is the P1, it is the P1, T2. Here the P1 is converted as a C1 ciphertext. It is also converted as ciphertext 2. Okay, and finally we will add these two and to get ciphertext. Okay, here what is the procedure? Here the procedure is the plain text is divided into number of block 1, block 2 up to block n and E- Each and every block will perform encryption with help of the key. Okay, after encryption, we'll get the ciphertext one for first block. Again, the second block, plain text, will perform encryption with help of the secret key. Same secret key will get ciphertext 2 and for block 2, and this procedure will be continue up to nth block plain text, and we are applying encryption with help of key. We are getting the ciphertext n. Okay, up to block n. This procedure is called electronic. This procedure is called electronic code book. Okay, clear. This is about the electronic code book. Okay, what is the second mode? The second mode is cipher block chaining. What is the meaning of cipher block chaining? In cipher block chaining, we will use the first block will given as the first block ciphertext. The first block ciphertext is given as input to the second block XOR operation. Okay, clear. Here the ciphertext of first block will give as input to second block. Okay, see here in first that again same as the plain text is divided into number of blocks. Here also is the first block. First block plain text with the help of the key we are performing encryption. We are getting the ciphertext. This is the first block ciphertext 1, and this ciphertext given as input to second block XOR operation. Second block XOR operation. Here the block 2 plain text with help of the XOR operation, and before previous block ciphertext we are performing XOR operation, and that result that will be go for again encryption algorithm with help of the key we are performing encryption. That is the ciphertext 2. Again this second ciphertext will taken as the input to the third block. This procedure will be continuous up to end of the block. End of the block again we are getting this ciphertext as the ciphertext will goes for the XOR operation will perform the and XOR operation that will be go to again encryption. We will get the ciphertext. Here the first block not applying XOR operation. Here first block not applying XOR operation. Okay, here we have to take initial vector. We have to take XOR. We have XOR with initial vector. Initial vector. Okay, and in this one, plain text is 64 bits. Then ciphertext also 64 bits. Why? Because in block cipher, what is the original size? The same size will get the ciphertext. What is the original plain text size? The same size will get as the ciphertext. And finally, after completion of all the blocks, we have to add P1 plus P2 plus P3 and so on. That equals to C1 plus C2 plus C3 and up to Cn. This is the this is the cipher text, and the next mode is cipher feed block. What is cipher feed block? In cipher feed block, the entire block cipher is converted into stream. Okay, it is very fast. No need to apply. No need to add any extra bit padding. It is real time application. Okay, see, we will see what is CFB. In CFB, the plain text length is same as the cipher text. In this, we have shift register operations. The size of the shift register is n bits. Okay, first we have to take initial vector. Okay, the entire block cipher converted into stream cipher. Okay, it is fast, no need bit padding. Okay, the size of the plain text is S bits, and we will encrypt the n bits of the top register with help of the key. Then, with the help of the key, then we will get n bits of the ciphertext. Actually, the size of the plain text is S bits. So, from the S bits, we have to select most significant bits, MFB. From then, n bits of ciphertext, we have to select S bits. Then, the S value should be 1 less than S less than N. Those S bits are perform XOR operation with the plain text. Then the final ciphertext will be given to the top register as feedback. Okay, this is the round 1 operation. In round 1, we'll use initial vector. Okay, here the round 1 operation ciphertext will given as next round shift register. The final ciphertext will given as to the top register as feedback to the second round. The top register will shifting towards the left side because in order to accommodate the ciphertext inside it, again we will have n bits will be encrypted by using the secret key. You will get a ciphertext. In that ciphertext, we have to select S bits. The S bits to XOR operation with plain text to get ciphertext. Again, we are getting S bits. Again, these S bits will go for next round shift register. Again, the same procedure will be repeated up to end of the last block. This is the first block, second block, this is the nth block, and finally we will get encryption. This is about the cipher feedback block. Okay, here what happened? The first initial vector we are applying to encryption with the help of the key. We are getting the S bits. In this one, we will get most significant bits. Those bits will be applied with XOR operation with plain text S bits. We will get the ciphertext. This ciphertext result will be go for next round shift register. Again, the same procedure will be continue up to end of the block to get ciphertext. This is called cipher feedback encryption. Okay, the next mode is OFB. OFB. What is OFB? It is same as cipher feedback block. Okay. It is same as CFB. Here, instead of plain ciphertext, output given as the feedback form. Okay. In previous one CFB, the output of the ciphertext we are getting the input. The ciphertext is we are taking as the input to the next round. But here we will not taking the ciphertext. We are taking the encrypted data we are getting as the input to the next round. Okay. Here what is the difference here? Here Instead of ciphertext, output given as feedback. Okay, the output refers as S most significant bits. Okay, here next point is output is S bits, M as the most significant bits. Okay, in first round we'll take non-C as the number in this the first round, and non-C and with the help of the key we are performing encryption. This cipher text, this output, this encryption output we are taking as the input to the second round, and after that this encryption result we are performing XOR operation with plain text one, we are getting the cipher text, and this X encrypted data will go for input to the second round. Here we are taking the initial vector, but here we are taking the output of the first round. Again we are performing encryption key. That result will be go for next round. The same data will be we are performing XOR operation with plain text 2. We are getting cipher text 2. Again this procedure will be continue up to end of the last block. End of the last block. Here in each round we will get in the ciphertext 1, ciphertext 2 up to ciphertext 1. Okay, what is the ciphertext here? Final ciphertext equals to ciphertext 1, ciphertext 2 up to ciphertext n. Okay, clear? This is about the output feedback. Output feedback. Okay, the last mode is counter mode. What is the meaning of counter mode? In counter mode, what will happen? In counter mode, instead of taking the plain text directly, we are giving it in the form of counter. Okay, taking a counter and giving a plain text in the form of counter. The counter size equal to plain text size. It is similar to electronic code book. Okay, clear? Here counter is placed in each and every block. Okay, see here it is the counter as the plain text, counter as the plain text, counter as the plain text. So what is the first point? Counter is placed in each and every block. Okay, completion of a block, counter value will be increment by 1 each and every block. Completion of a block, counter value incremented by 1. Okay, if first round is completed, the value become incremented by 1. Okay, initially we will take initial vector as a counter. With the counter value, we are performing encryption with the help of the key K, and after that, what is the data we are getting? We are getting the encrypted data. That encrypted data will be applied for XOR operation with the help of the plain text, and we are getting the ciphertext one. This is the first round. Okay, the second round, again the encrypted data. Again in the second round, again we are taking the counter. This is the initial counter here. Counter increment by 1. So counter with the help of the we are performing encryption. Okay, with the help of the key we are performing encryption, and after that we are getting the ciphertext. That ciphertext again we are applying XOR operation with the help of the plain text 2. We are getting the ciphertext 2, and this is the next mode. This is the next round up to nth round. Here we are taking the counter n minus 1, and we are applying the encryption with help of the key K, and the result is ciphertext. The ciphertext again we are applying for XOR operation with help of the plain text and to get counter and. Okay, this is the counter mode. This procedure will be started from starting to up to end of the last block. Okay, initial block we don't have any initial block we are taking as the initial vector as the counter. Okay, in decryption the same procedure will be continue to get ciphertext to plain text. Suppose what is the thing here? It is the encryption. So we are taking the plain text. We are getting the ciphertext. Suppose it is the decryption method. We are taking the ciphertext here. We are getting the plain text as the output. Same as here also taking the ciphertext to. We are getting the plain text to. Here ciphertext and we are getting plain text and okay in decryption. The remaining procedure is same in counter block. This is about the block cipher operation. If you have any doubts, please ask me in comment section. Thank you. Hello everyone, welcome to my YouTube channel Concept Clear. In today's class, we will discuss about stream cipher in the subject of cryptography, network security. Okay, what is stream cipher? Here, the stream cipher is nothing but the plain text is divided into number of substreams. Okay, like block cipher only. Okay, here the plain text is divided into number of streams. Okay, here in the block cipher, what will happen? In block cipher, the data will be divided into number of sub-blocks. Okay, at the time of conversion, each block will be converted as ciphertext. Here also in stream cipher, the plain text is divided into number of streams. Here, each stream is nothing but number of bits or bytes. Okay, here the data will be converted as from plain text to ciphertext as one bit at a time. At a time in stream cipher, the plain text is divided into number of substreams. Here, one bit will be converted as plain text to ciphertext at a time. Okay, in stream cipher, it is a symmetric key cipher that takes the same key for encryption as well as the decryption. Okay, stream cipher is a symmetric key cipher that uses same key for encryption as decryption, but unlike a block cipher, a stream cipher operates on each digit of the plain text to produce the ciphertext. Okay, what is this? In block cipher, it will convert entire block at a time from plain text to ciphertext. But in stream cipher, it operates on each and every bit of plain text to produce ciphertext. It means what? Each and every bit will be converted as from plain text to ciphertext. Usually here a bit of data combining with XOR operation. Okay, here a bit that will combining XOR operation to produce ciphertext. There is nothing but the plain text is converted as a ciphertext. Here we will perform XOR operation. Here we will perform XOR operation. Here what is the diagram for stream cipher is here plain text perform XOR operation. Here it will take a key generation. Okay, key stream generator. Here this will produce keys. It will produce the keys. With the help of this the key with plain text we will perform XOR operation. Then we will get ciphertext. Then we will get ciphertext. The same ciphertext will be transferred to this the sender side. The same ciphertext will be sent to right side, the receiver side. Here again we will perform one more XOR operation with the help of the key stream generator. Key stream generator to produce plain text. Okay, here we are getting ciphertext. Okay, see, this is the stream cipher operation. Actually the plain text is applied to XOR operation with the help of the key stream generator. It will produce one key with plain text and secret key. We are performing XOR operation to produce the ciphertext. The ciphertext will be delivered to the receiver side. Again here we are performing XOR operation with the same key stream generator key with to produce the plain text. Okay, here we are performing bitwise XOR operation. Here also bitwise XOR operation. Okay, here to produce, here we are performing encryption. Here we are performing decryption. Okay, here a stream cipher consider each and every bit one by one. Okay, it will converts plain text to ciphertext each and every bit at a time. Okay, stream cipher consider each and every bit one by one to produce plain text to ciphertext. Plain text to ciphertext. We will see one example. Here suppose the plain text is P1, P2, P3 and so on Pi. It is the plain text. Okay, assume this is the plain text. And key, what is the key? K1, K2, K3, 4 up to Ki. It is the key. Okay, and here we are performing XOR operation. We are performing XOR operation. What is the result? After result, P1 with XOR operation with key 1 is ciphertext 1, ciphertext 2, ciphertext 3, 4 and up to CI. Okay, it is the ciphertext. Okay, it is the ciphertext. Here, what is the formula here? Here, this is the ciphertext. And what is the formula to decrypt? To decryption formula is ciphertext XOR operation with the key equals to plain text for decryption. So again we have to perform the operation between C1 K1, C2 K2, C3 K3 and so on, Cn Kn. What is the result? P1 P2 P3 Pn. Here what is the ciphertext, it is the key and this is the original plain text. Here we have to perform XOR operation. Here we have to perform XOR operation. We will see one with a example. Okay, we'll see with a example. For example, I am taking plain text is 1100 and key is 1011. Okay, to convert ciphertext, we have to perform bitwise XOR operation. Okay, in bitwise XOR operation, what is the bitwise XOR operation? If both bits are different, then the value equals to 1. Okay, here both are different, then the value equals to 1. Otherwise, the value is 0. In bitwise XOR operation, here both are different. So what is the result? 1. And here also both are different. So what is the value is 1. Here both are different. What is the value is 1. And what is the both value? 0. Okay, 0. So this is the plain text. This is the with help of key we are creating the cipher text. Okay, this is about up to encryption. Okay, this is the encryption. Okay, I said this is the encryption. And again, this is the cipher text. Again, what we have to take? We have to take a key to convert plain text. So here I am taking what is the key here? Same key we are using. This is the key is 1011. Okay, here we have to perform bitwise operation. Again, we are performing decryption. So here we are performing decryption. So what is the decryption result is plain text. What is the plain text here? Both are different. We will get 1. See, otherwise we will get 0. 1 1 same. So 0 1 1 same. So 0 1 0. So different 1 0 1 different. So 1. So what is the plain text here? 1 1 0 0. And what is the original plain text is 1 1 0 0. So both plain texts are same. Okay, here what is the plain text we are used first time 110, and after encryption we are getting 0111. After decryption we are getting 110. So this is the stream cipher. So example value is same. Plain text is same. Here also plain text is same. So this is about the stream cipher. Okay, if you have any doubts, please ask me in comment section. Thank you.
Hello everyone, welcome to my YouTube channel. In today's class, we will discuss about RC4 in the subject of cryptography network security. What is RC4? RC is nothing but reversed cipher. Okay, it is RC4 means reversed cipher. It is a stream cipher. What is meaning of stream cipher? Stream cipher is nothing but the plain text is divided into number of streams. Okay, previously we seen what is block cipher. In block cipher, the plain text is divided into number of blocks. Same here also. A stream cipher is nothing but the plain text is divided into number of substreams. Okay, number of substreams. It is a RC4 is a symmetric key encryption algorithm. What is the meaning of symmetric means? Symmetric key is nothing but what? Here we will use the same key for encryption and as well as the decryption. Okay, if any algorithm uses a single key for encryption and same as the same key used for decryption, those algorithms are called symmetric key encryption algorithm. Okay, here RC4 is also one of the symmetric key algorithm. In 1987, Roland Rivest, he is the scientist. It is the scientist name. He designed Rivest cipher. Okay, Roland Rivest is the developed the Rivest cipher. It is a stream cipher used. It is a stream cipher. It is used for data communication and network protocol. Mainly, it is used for data communication while transferring the data over the network. In those cases, we will use the RC4 algorithm. Okay, in stream cipher, it generates a it generates a sequence of key. Okay, here RC4 stream cipher generates sequence of it generates key stream. What the meaning of key stream means? Key stream is nothing but sequence of keys. Sequence of keys. Okay, in encryption algorithm, it performs by combining a key stream with plain text. Usually, it will perform XOR operation to perform the ciphertext. Okay, see here in encryption algorithm. In encryption algorithm, it will performs the operation by combining key stream with plain text. Key stream with plain text. Usually, it will perform XOR operation. Usually, it perform XOR operation to get ciphertext. XOR operation to get ciphertext. Okay, here RC4 algorithm mainly follows 3 steps. RC4 algorithm follows 3 steps. What are the 3 steps here? First step is key scheduling algorithm. First step is key scheduling. Second one is key stream generation. And third one is encryption and decryption. Second one is key stream generation. And last one is encryption and decryption. It is the encryption and decryption. Here we will see one by one what is key scheduling, what is key stream, and what is the encryption and decryption. Okay, here what is the operation will be performed by RC4 means it will take plain text and with perform XOR operation with what? With key stream. Here, what is the meaning of key stream means? Key stream is nothing but sequence of the keys. Okay, here key stream contains what? Secret keys. Okay, RC4 secret keys. And after performing plain text, with key stream with plain text, performing XOR operation, what? To produce what? To produce ciphertext. Is the ciphertext. Okay, this is the block diagram of RC4. This is the block diagram of RC4. Okay, clear. And we'll see what is the steps, what is the thing happening in key scheduling algorithm, key stream generation, and as well as the encryption and decryption. Okay, first we will see key generation. What is the meaning of key generation? What is the meaning of key generation means? Here key generation is nothing but key size is variable length. Okay, here the generally the key size is variable length. Okay, when you are generating the key size, it contains the length of the key, variable length key size, that is varies between 1 to 128, sorry, 1 to 256 size. The range is 1 to 2 to 256 size. And next one, here for 256 entries, okay, if you have 256 entries, a key is generated k. Okay, for every 266 entries, a new key is generated. A key is generated. That generated key is called first round key. Okay, the next step is key scheduling. Okay, this is about the key generation. And next one is key generation. What is the meaning of, sorry, what is the meaning of key scheduling? Okay, this is about the key generation. Next one is key scheduling. What is the meaning of key scheduling algorithm? Here we need to take what is the meaning of key scheduling here? Here we need to take S or A equal to values from 0 to 25. 0 to 225. Here we have to take a 225. 0 to 225 in number of iterations or number of iteration. Number of iterations means what? How many times you have to write? Okay, number of iterations are equals to size of S array. Here we have to take S array contains 0 to 255 values. The values are 0 to 255 values. Okay, 0 to 225 values. Okay, here we have an algorithm. For this one, we have an algorithm. What is the algorithm here? J equals to 0. Okay, for time doing, I am writing this algorithm first. Then I will explain. Here, this is about algorithm for key scheduling algorithm. Here we need to take an S array that is equals to values 0 to 255. The number of iterations equals to size of S array. Okay, here I am taking S j equals to 0 for I equals to 0 to 255. It means we have to run 255 time iterations. And here what is the j value then? J equals to j plus S of I value plus T of j value mod 226. And after performing every time this run, after running this time, every time we have to perform the swap operation. Here swap operation means what? Here S of I value, S of j value will be swapped. Both time the S of I value and S of j value will be swapped. Okay. Here it is also S of j1. Okay. This of j value. Here both values will be swapped. After every iteration, the operation values will be swapped. Okay. This is about the key scheduling algorithm. Here, what is the meaning of S of I? Here, S of I is nothing but state vector. Here, S of I is, sorry, actually, this is the T of I only. Don't confuse. Here, S of I equals to state vector. And what about T of I? T of I is nothing but array temporary vector. Array temporary vector. Okay, this is about the key scheduling. Next one, we will see key generation. What is the meaning of key generation? Here, key generation. Again, we have one more algorithm here. For time being, I am writing and I will explain. Okay, here key generation algorithm is the I comma j equals to 0. While it is the condition is true, then what is the iteration we have to perform? I equals to I plus 1 mod 256. And what about j value here? J equals to j plus S of I mod 256. Here, after performing every iteration, we have to perform swap operation S of I comma S of j. And what is the t value here? The formula for t equals to S of I plus S of j mod 256. Okay, after that, here we have to perform swap operation. Okay, for example, if you see S contains the values are 0, 1, 2, 3, 4, 5, 6, 7. Assume these are the 8 values. Okay, here K equals to 1, 2, 3, 6 and plain text equals to 1, 2, 2, 2. Okay, and if you implement these values in here, okay, if you implement these values here, what is the I value here? Here I equals to 1, I equals to 1 to 7. We have to perform I equals to 1 means 0. So I equals to 1 to 7 we have to perform. Next, what is the I value? Next time 2. And what about 2 to 7 we have to perform? 3 to 7. Like that 7 to 7 we have to perform. Okay. Here after swapping, suppose if you swap s of 0 plus, sorry, s of 0 comma s of 1. Okay, and what is the value here? 1 mod 8. So what is the value here? 1. So the value is 1. So we can write j equals to 0 plus, in the formula j equals to 0 plus and 0 plus 1 mod 7. So what is the value here? 1 mod 7. The value is 1. Okay, and what based on this, what is the t value here? T value is 1, 2, 3, 6. 1, 2, 3, 6. So here S equals to T. S equals to T. Next, and what is the, these are about the key generation algorithm. These are the key generation algorithm. Okay, next, and what about encryption and decryption? Here encryption and decryption, for encryption and decryption. Okay, this is the third step. Here in encryption and decryption, we have to take left side initial vector, and right side have to take secret keys. Okay, here after initial vector, we will apply SRA elements, and what about the secret key? We will apply T array. Okay, we'll apply, it contains the T array. Okay, T array elements, and after that we have to permute S array with T array by KSA, key stream algorithm. Key stream algorithm, KSA. Okay, after that again we have to permute by R, we have to permute with PRGA. What is the meaning of PRGA? Means pseudo random generator algorithm. Okay, it is nothing but pseudo random generation algorithm. Okay, it will generate a key stream, generate algorithm. Okay, after performing this PRGA, it will generate a key stream. Okay, by using this key stream, we will perform XOR operation with plain text to get ciphertext, and same diagram for decryption also. We will perform this key stream with XOR operation to get ciphertext with plain text. Suppose if you want to get plain text means you have to perform the key stream with XOR operation with ciphertext with XOR operation. You will get the plain text. Okay, this is the this is the common diagram for encryption and decryption. Suppose if you are performing encryption, you will perform key stream with plain text. XOR operation will get the ciphertext. Suppose if you are performing decryption means key stream will perform the ciphertext. Will get the plain text. Okay, this is about the reversed RC4 algorithm. Here, what is the main thing in RC4 algorithm means it is a uh, symmetric key encryption. Okay, it is RC4 is a stream cipher algorithm. What do you mean of stream cipher means the plain text, the given plain text data will be divided into number of substreams. Okay, this is about the RC4. If you have any doubts, please ask me in comment section. Thank you, everyone. Please subscribe our YouTube channel. Concept clear.
నా ఛానల్ పేరు గుర్తుందిగా, ప్లీజ్ లైక్, షేర్ అండ్ సబ్స్క్రైబ్. ఏంటి
Everyone, welcome to my YouTube channel. Today's class will discuss about principles of public key crypto system in the subject of cryptography network security. Okay, here public key cryptography. Public key cryptography is also called asymmetric cryptography. Okay, what is the meaning of asymmetric or public key? Okay, before discussing asymmetric key, first we should know what is symmetric key. What is symmetric key? In symmetric key cryptography, a single key used for encryption and as well as the decryption. Okay, here we will use a single key at sender side for encryption, and the same key will use the receiver side to decryption. Okay, this procedure is called symmetric key cryptography. Okay, here key is transferred from sender to receiver. Okay, while receiver to decrypt the data. While transferring from sender to receiver, there is a chance for hacking. Okay, so to overcome this problem, asymmetric or public key cryptography is developed. Okay, this is the drawback. To overcome this asymmetric or public key cryptography. Okay, what is the asymmetric or public key cryptography? In this one, a pair of keys used for encryption and decryption. Okay, what is the pair of key? The pair of key contains two keys. The first one is public key, second one is the private key. Okay, what is the meaning of public key? Public key is used for encryption and private key is used for decryption. What is public key? Public key is known by everyone. Public key is known by everyone. So it is the openly known by all the people. Public key. And what about the private key? Private key is known by only receiver. Okay, it is known by everyone. And what about this by known by only receiver? Okay, what are the main elements in this public key cryptography? The elements are, the first one is plain text. What is the plain text? The plain text is nothing but is the original message. It is the original message which will be converted as known, which will be converted as ciphertext. It is the input. It is the input of encryption. It is the input of encryption. This data will be converted as plain text. Okay, the second element is ciphertext. What is the ciphertext? What is the ciphertext? Human unreadable message is the output of encryption. Is the output of encryption. Okay, next. The third element is encryption algorithm. What is the encryption algorithm? Here, encryption algorithm is nothing but which will convert plain text into ciphertext. Okay, with the help of public key. Okay, with the help of the public key. That is the encryption algorithm. And next element is keys. Here, what is the key? Key means here we have two keys. The first one is public key. Second one is the private key. Public key used for encryption, used for decryption. And next one is decryption algorithm. What is the decryption algorithm? Decryption algorithm which will convert ciphertext into plain text with the help of private key. With the help of the private key. Okay, we will see the procedure of we will see this is with the help of the diagram. The procedure for sending message to receiver, both sides. Okay, procedure for sending message sender to receiver. Okay, first both sender and receiver generates a pair of keys. What is the pair of keys? These are public, private key. Public key means what? Access all, access receiver only. Okay, first is the sender. Again, is the sender. Okay, sender will generate a message. The sender will generate a message that will be sent into encryption algorithm. Encryption algorithm. Okay, this is the message X. Suppose the message X is sending. Okay, here encryption algorithm, we are taking public key. After encryption, we converted ciphertext. This ciphertext data is traveled over the network. Here, the ciphertext will apply to decryption algorithm with the help of private key. Again, the ciphertext will be converted as X. That is the message and receiver. Okay, this is the sender sending a plain text message X that will be applied to encryption algorithm with help of the public key. And after public key, we are getting ciphertext. The ciphertext travel over the network, and the ciphertext at receiver side go to the decryption algorithm with help of the private key. The data is encrypted, decrypted. We are getting the same as original plain text. That message is delivered to the receiver side. Okay, in reverse, and this is the public key encryption. What about the decryption? It is similar to reverse, the same procedure in reverse. In reverse mode, what will happen? First, plain text in the place of the in the plain text. Okay, okay. Here again, receiver in the sorry in the reverse also will perform. Encryption is, suppose at the time of encryption we can also give private key. Here we can give public key. Okay, these two procedure is called authentication. These two procedure is called authentication. And one more thing here, what is the main point is we can also perform multiple encryptions and decryptions for to provide more confidential ciphertext data. That is nothing but here is sender message. Here the sender message that is the X is the plain text that with the help of the encryption algorithm will convert here with the help of the public key. Okay, will perform again. We will perform again one more encryption algorithm with the help of private key. Okay, there is a key source. There will be a key source. Again, the this X is the Y. This will be traveled network at receiver side and receive Y. So here in decryption algorithm, what is the first time they are used private key? Okay, private key. Again, here is a key source. Here public key A, private key B. Again here it will take the key is public key A, and then we will get X. Again, sorry, it is the Z. G are receiving Z. Again, we are getting Y. So again, we are in decryption of private key of B. Private key of B. And finally, we get the original message. Okay, which is the receiver side. Okay, like this, to get more confidential data, more confidential data, you can use multiple types of encryption and decryption. Okay, thank you. If you have any doubts, please ask me in comment.
In today's class, we will discuss about RSA algorithm in the subject of cryptography network security. What is the meaning of RSA algorithm? RSA is a public key encryption algorithm, was developed in 1977 and published in the year of 1978. Okay, RSA was developed by totally three scientists. They are Ron Rivest, Adi Shamir, and Len Adelman. Okay, with their name Rivest, Shamir, and Adelman. Okay, because of their names, they declared the algorithm name is RSA algorithm. Okay, RSA scheme was supreme as widely accepted and implemented approach to public key encryption. Okay, RSA is a block cipher. What is the meaning of block cipher first? A block cipher is nothing but the plain text is divided into number of subparts, and after encryption also we will get the same size of the ciphertext message. Those that is called block cipher. RSA is a block cipher in which the plain text and ciphertext integers between 0 to n minus 1. Okay, there is a range is 0 to n minus 1 for some n. Okay, for some n number. Okay, here encryption and decryption are encryptions or decryptions are following form period at the same time. Okay, here the what is the meaning of what is the plain text? A plain text is nothing but human readable format is called the plain text. Where we will denote the plain text with M. And what is the cipher text? Cipher text is the human unreadable format is called the cipher text. That was denoted by C. Here to convert cipher text to perform encryption. Encryption means what? Encryption means after encryption you will get the cipher text. So cipher text C equals to M power E mod N. And the plain text to perform the decryption, the plain text means M. So M equals to C power D mod N. Okay, if you write, finally we will get M equals to M power ED mod N. Okay, here C is the ciphertext. Don't confuse. M is the plain text and E is the public key. E is the public key and D is the private key. Okay, first of all, first point. Here I already told that if RSA is the public key encryption, RA is the asymmetric key encryption cryptography. What is the meaning of asymmetric? Asymmetric is nothing but here two keys for used for encryption and decryption. The two pairs of keys. What are the two pairs of keys? The first one is public key and second one is the private key. Okay, in asymmetric key encryptions, we'll use the a pair of keys. First one is the public key for encryption, second one is the private key for decryption. Okay, if any algorithm, if you use the two keys for encryption and decryption, those algorithms are called asymmetric key cryptography or public key encryption algorithms. Okay, now see here both sender and receiver must know the values N and E. N and E. E means what? E is the public key. Here, if you are the sender, you should know the public key, and the receiver also know the public key. And the receiver only knows D value. What is the D value? Private key. Okay. Here the sender also don't know the what is the secret key. Okay. What is the private key? The private key is known by the only the receiver. Only the receiver. In the public key encryption algorithm, The public key encryption algorithm with public key of KU. We generally will write the KU. KU is the public key. With what is the public key here? E comma and what is the E? E is nothing but public key, comma N is the product of the value. Okay, we will see what is the N value in upcoming in this video only after 2-3 minutes. Okay, and what about the private key? Private key is KR equals to D comma and again what is the meaning of D? D is nothing but private key and N value we will see here. Okay, next in RSA algorithm contains majorly 3 steps. In RSA algorithm we have majorly 3 steps. What are the 3 steps means? The first one is key generation, second one is encryption and third one is the decryption. Okay, first one is key generation, encryption, decryption. We will see what is the key generation. Here in key generation we have to follow some steps. What are the first step? In key generation we have to follow some steps. The first step is we have to take or we have to select 2 prime numbers. Okay, we will mention that 2 prime numbers are P and Q. And then second step is calculate the product of N. Okay, before that in the public key and private key we seen what is the N value. The product of 2 prime numbers is N, that is the P into Q. And the third step is we have to in third step which is the modulo for encryption and decryption. Next we phi of N referred to as Euler coefficient value of N. Okay, there is a Euler coefficient value, but according to our syllabus we don't have that one. What is the to have to calculate the phi of N, or what is the formula for phi of N here? Phi of N value is P minus 1 into Q minus 1. According to key generation, the phi of N value is P minus 1 into Q minus 1. P minus 1 into Q minus 1. Okay, what is the fourth step? Select an integer E. Here we have to select an integer B that is relatively to prime to phi of N. Okay, that means the greater common division of E and phi of N is 1. Okay, so the range is 1 less than E less than phi of N. Here what is the phi of N value? The phi of N value is 187. If you perform, sorry, what is the phi of N value? We will see with example. Okay, next, what is the next step is to calculate D as multiplicative inverse of E. Inverse of E modulo psi of N. So what is the formula here? D is x into phi of N by E plus 1. Here the D is, we can also write like this. D is E inverse modulo of phi of N. Okay, and what is the public key? Next step is we have to develop the public key. Public key is KU equals to E comma and private key KR equals to D comma and. Okay, this is about the key generation. This is the first step is key generation. What is the second step? To perform the encryption algorithm, and third step is to perform the decryption algorithm. Okay, see here. To perform encryption algorithm, to calculate the encryption, the formula is C equals to m power E mod N. C equals to m power E mod N. And what about the decryption? Decryption is m equals to C power D m mod N. Okay, if we can also write like this. And what is the example? Okay, here this is the first step, key generation. Second step is the key encryption, and third step is the decryption. Now we will see one example for this RSA algorithm. Okay, example. In this example, I am taking example. Here, what is the first step? The first step is begin 2 prime numbers P and Q. So I am taking first one, prime number P equals to 17 and Q equals to 11. Okay, I am selecting 2 prime numbers. What is the next step? Calculate the product of N. So for product of N, so P equals to, what is the N value? N equals to P into Q. So what is the value? 17 into 11. If we calculate, we will get, what is the, how much we will get? We will get 187. The second step is 187. And what is the third step? Calculates phi of n, that equals to P minus 1 into Q minus 1. So the third step is phi of n equals to P minus 1 into Q minus 1. So what is the value? 17 minus 1 into 11 minus 1. So we will get 16 into 10. So what is the value? 160. Here we are getting n value is 187. Here we are getting 160. Okay. And what is the fourth step? In the fourth step, select an integer e relatively q of n. That means greatest common divisor value of e and phi of n. So we have to check e value and phi of n value. What is the greatest value here? E means what? E means what? E is nothing but, what is the e value? E is nothing but public key. We have to check with public key and with phi of n value. So what is the phi of n value are getting here? 160. So in the fourth step, we have to calculate the GCD of 160 comma first one is 11. Okay, it means if you calculate this one, the remainder is 6. So it is a not prime number. Okay, if it is prime number only, we will consider it is not a prime number. Okay, so here what is the formula we are taking? We are taking the formula is GCD of phi of n comma e, that equals to 1. This condition has to be satisfied. Okay, it is not possible. And next one, GCD of 160 comma 17. If you perform this, remainder is 7. Remainder is 7. So it is what? It is the prime number. The 7 is the prime number. So it is accepted. So E value equals to 7. So according to this, E value equals to 7. What is the next fifth step? Fifth step is calculate D value. What is the formula here? D equals to x into phi of n by e plus 1. So fifth one is to calculate D equals to demand 160, that equals to 1. So here D equals to x into D equals to x into psi of n by e plus 1. That is the formula. Here where x we have to check with 1, 2, 3. We have to check the x value. Okay, which is divisible by 1. Okay, the result has to, what is the result we are getting? That is should be divisible by 1, 2, 3. Okay, then I have to check. The value x is either 1, 2, 3. You have to check which value is the divisible. Okay, next here I am checking 1 into 160 by 7. E value is 7. So plus 1. Okay, that means 160 by 7 plus 1. Okay, here we are taking 7 into 160. What is the value? 22. So here divisible. So it is the x equals to 1 is correct. Okay, we are considering x equals to 1. So 22 plus 1 is 23. So what is the D value? D equals to 23. What is the D value? D is the secret key. D is the secret key. See here what we see. D is the private key. D is the private key known by the only receiver. And what is the sixth step? The sixth step is we have to generate the public key. Public key KU equals to E comma. Next, public key KU equals to E comma n. What is the E comma n value? E is 7, n value is 187. Okay, next, what is the private key we have to consider? Private key KR equals to D comma n. What is the D value here? D value is 23 comma n value is 172. Okay, according to this public key and private key, we have to perform the RSA algorithm. Okay, here I am taking one more example to show you. This is the RSA example. Here I am taking the plain text is 88 and the plain text initially we are taking the plain text is 88 and it goes into encryption algorithm. What is the encryption formula here? C equals to m power e mod n. Okay, I am implementing the values here. What is the C equals to m power n? What is the m value here? M value is plain text is 88. So plain text is 88. So m means 88, e value is 7. So mod 7 mod and n value is 187. So here this is the formula we are implementing like this. If you calculate 8 power 7 mod 187 equals to the result is 11. Okay, it means what? The plain text is 88 is converted as 11 and the 11 is transferred over the network, okay, over the network the 11 value is transferred. Okay, so what is the original data is 88, that is converted as 11 and receiver side to display the data, what I have to do, the data has to be displayed as the plain text. So here we are performing decryption algorithm. What is the decryption algorithm? M equals to C power D mod n. Here M value is what? M value is 88. So sorry, we have to get the 88. So what is the C value? C value is 11 and D value is 23. So 11 power 23 mod 87. M means 87. If we calculate this one, we will get the 88 M value. Okay, this is the encryption side, this is the decryption side. Okay, don't confuse here. Some textbooks they referred as the private public key as the KU. Some other textbooks they given as the PU. Okay, both are same. Okay, here also KR and PR. Okay, it is the public key, it is the private key. Okay, when you are writing this exam, please carry your calcs because we have to calculate these lengthy values to get the proper results. Okay, thank you. Okay, this is about the RSA algorithm. What is the algorithm? The RSA algorithm means it is the asymmetric key public key. It is the asymmetric key encryption algorithm or it is the public key encryption algorithm. What is the asymmetric or public key means? Here we will use the two keys for encryption and decryption. Okay, these type of algorithms are called public key encryption cryptography or asymmetric key cryptography. Okay, it is the very important question in the semester exams. RSA algorithm. Don't confuse here. If you have any doubts, please ask me in comment section. Thank you everyone.
Hello everyone, welcome to my YouTube channel Concept Clear. In today's class, we will discuss about LGML cryptography algorithm in the subject of cryptography network security. Okay, first of all, what is LGML algorithm? LGML algorithm is a asymmetric key cryptography. It is asymmetric key cryptography. We can also call public key cryptography. What is the meaning of asymmetric key cryptography? Asymmetric key cryptography is nothing but here we will use a pair of keys for encryption. A pair of keys means here we have two keys. First one is public key and second one is the private key. Okay, here we will use two keys for public key and private key for encryption as well as the decryption. Okay, LGML algorithm is invented by LGML in 1985. Okay, here in LGML algorithm mainly used for digital signatures. It is mainly used for digital signatures and digital transactions. Digital signatures and digital transactions means online transactions. Okay, clear? Next, in LGML algorithm, we have mainly three steps. It contains three steps. The first one is key generation. Second one is encryption. And third one is decryption. Okay, what is the first step? In key generation, we will generate public key and private key. Okay, key generation. In this key generation, we will generate two keys for encryption as well as decryption. Okay, here in key generation we have to follow some several set of steps. The first step is step 1. Select a large prime number. Select a large prime number p. Okay, here in the same time we'll consider one example also. Here I am taking the prime number p and I am assigning value is 11. Okay, assigning the value is 11. Next, step 2. Select a decryption key. Decryption key means what? Private key. Decryption key is called decryption key or private key D. Here I am taking D equals to 3. Okay, I am taking here randomly. Okay, here there is a condition D should be 1 less than or D equals to P minus 2. P minus 2. It is a random number. It is a random number. Okay, and what is the third step? Third step is we have to select second part of encryption key. Okay, select second part of encryption key, that is E1 equals to, I am taking E1 equals to 2. Okay, it is primitive root. Here I am taking E1 equals to 2. And what is the fourth step? Fourth step, we have to select third part of encryption key, E2. Here to find out E2, we have a formula. E2 equals to E1 power D mod P. This is the formula for E2. Okay, here if you have implement above values in this E2 equation, we will get what? 2 power 3 mod 11, that equals to 8 mod 11, that equals to 8. 8 mod 11 equals to 8. So what is the value here? E2 equals to 8. And what is the fifth step? Fifth step is here we have to find out public key. Okay, we have to find out the public key. Find out the public key. What is the public key here? The public key equals to E1 comma E2 comma P. And so what is the E1 comma here? The public key equals to E1 equals to what? E1 equals to 2, E2 equals to 8, P equals to, we are taking the large prime number 11. So this is the public key. And what is the private key here? Private key is D equals to, what is the D value we are taking here? We taken D value equals to 3. So this is the public key, this is the private key. So in first step, key generation, we generated a pair of keys, public key and private key. Next, what is the next step? Next step is encryption. We have to follow encryption. What is meaning of encryption? Encryption is nothing but converting plain text into cipher text. Okay, what is encryption here? Converting plain text into cipher text is called encryption. Okay, here in this encryption we have to follow some set of steps. The first step is we have to select a random number. We have to select a random number R. Okay, in the group of G, equals to Z power P comma X. Okay, here I am taking R equals to 4. I am taking the randomly R value equals to 4. Okay, don't confuse. and this is the step 1. Step 2, what is the step 2 here? Step 2 is we have to calculate C1 ciphertext value. What is the C1 value formula? C1 equals to E1 power R mod P. This is the formula for C1 ciphertext 1. And ciphertext 2 equals to, what is the formula here? Pi. Pi is nothing but plain text of E2 power R mod P. Okay, these are the two formulas for finding ciphertext 1 and ciphertext 2. Okay, here first one, step 3. In step 3, what is the C1 value? We have to find out the two values. C1 equals to E power 1, E1 power R mod P. What is E value here? Here E value is 2, R value equals to 4, E power 4 mod 11, that equals to 16 mod 11. So what is the value here? C1 equals to 5. We are getting C1 equals to 5. And what about C2? C2 equals to, what is the formula here? Pi. Pi is nothing but plain text. Here Pi is nothing but plain text. Pi equals to plain text ante Pi. So assume taking as a Pi value is 7. I am taking Pi value ante plain text is 7. Okay, don't confuse. I am randomly taking Pi value equals 7. So if you are implementing here, what is the value here? 7 into E2 value is E2 value. What is the E2 value? 8 whole power 4 mod 11. So what is the value? 28,672 mod 11. If we calculate, we will get 6. So what is the C2 value equal to? C2 equals to 6. C2 equals to 6. So what is the final ciphertext? Ciphertext is C1 comma C2, that equals to 5 comma 6. The final ciphertext is 5 comma 6. This is the encryption. Clear? This is the encryption. What is the next step? In the next step, we have to decrypt the data. Decryption. Okay, here we have to follow decryption. Okay, what is the meaning of decryption? Decryption is nothing but converting ciphertext into plain text. So converting ciphertext to plain text is called decryption. Okay, here we have to find out the plain text. So plain text equals to E2 C1 power D whole inverse mod P. This is the formula for converting ciphertext into plain text. Here, what is the value? E2 value is 8 and into C1 value, what is the C1 value? 5 power D value is 3. Check here, D value is 3. So power 3 whole inverse mod 11. So if you calculate this one to 8 into 25 mod 11. So 150 mod 11, that equals to 7. So what is the plain text here? 7. So what is the previous plain text we are taking here? We taken, assume the plain text is 7. That plain text 7 is encrypted as the 5 comma 6, and after decryption also we got 7. So this is about the LGML algorithm. What is the plain text where assumed 7? After encryption, that bit is converted as 5 comma 6. Again, the plain text is converted as 7. So this is the LGML cryptography algorithm. What is the LGML cryptography algorithm means? It is the asymmetric key cryptography. Asymmetric means we have to use two keys, public key and private key. We have to follow three steps. First one is the key generation, encryption, decryption. Okay, if you have any doubts, please ask me in comment section. Okay, everyone, please like our videos and subscribe our YouTube channel, and also share it with your friends. Thank you. Hello everyone, welcome to my YouTube channel Concept Clear. In today's class, we will discuss about Diffie-Hellman key exchange algorithm in the subject of cryptography network security. Here, what is Diffie-Hellman? Diffie-Hellman is one of the key exchange algorithm. It is not a encryption algorithm. It will works between two parties, sender and receiver. Here, the whatever the key we are using for encryption, the same key will be exchanged from sender to receiver. Okay, it is not providing any cryptographies. Okay, here key exchange is not a practically possible. Here key exchange is not practically not possible. This problem is called key distribution or key exchange problem. This problem is called key distribution problem or key exchange problem. It inherently linked with symmetric key cryptography. This algorithm can be used only for key agreement, not for encryption and decryption. Okay, it is the one of the key exchange algorithm. It is not provided any decryption and encryption. Okay, we will see this algorithm. We will see this algorithm. The first step is step 1. Here, sender and receiver both agree and select both will agree two large prime numbers n and g. Okay, they have to select two large prime numbers n and g. These two numbers need to be secret, can be shared, no need to keep secretly, they can share publicly. Okay, no need to be secret. Okay, can be shared publicly. Okay, the second step is the sender choose another large random number. Sender choose another large random number x and calculate a value a equals to g power x mod n. Then sender sends this a value to receiver. Sender sends this a value to receiver. And what about receiver side? Fourth step, receiver choose another random number y and calculate b value. B equals to g power y mod n. He will calculate b value. Next, again receiver sends b value to sender. And what is the next step? Sixth step is sender computes secret key k1 that equals to k1 equals to b power x mod n, that is the k1 value. This is the k1 means secret key 1, secret key 1. Okay, next step, the receiver also has to calculate k2 value. Next step 7. What is the step 7 here? Receiver computes his secret key k2 equals to a power y mod n. Okay, this is the second, another secret key k2. Okay, next, what is the last step in step 8? k1 equals to k2. Key exchange, see, key is exchanged successfully. If k1 equals to k2, then we can say key exchanged successfully completed. Okay, this is about the Diffie-Hellman key exchange algorithm. Here we won't provide any encryption and decryption. Here we have to exchange the secret keys from sender to receiver. Okay, what is the algorithm here? First we have to take sender and receiver, both two large numbers, n comma g. Then we have to calculate, we have to take one more random number x. Sender will be take one more random number x and calculate a, and the sender will be sent a value to the receiver. Next one, receiver chooses the another random number y, calculate b value, and the receiver sends the b value to the sender a. And finally sender will be calculate the secret key k1, and as well as receiver will be calculate the secret key k2. If the both keys k1 and k2 are equal, then key exchanged successfully. We will see one example. Here we will see one example. Here the first step 1, sender and receiver agree to large prime numbers n equals to 11, g equals to 7. Okay, assume this is the sender, computer, this is the receiver computer. Assume this is the sender and receiver. Okay, sender and receiver. And what is the second step? In second step, the sender choose, what is the second step? Sender choose another random number x. So here sender choose another random number x equals to 3, and he will calculate third step. What is the third step? He will calculate a value, a equals to g power x mod n. He will calculate this ga value and j value. So what is the value here? The value is, what he will get? He will get 7 power 3 mod 11, that equals to 2. So a equals to 2. Okay, the save equals to 2. And what about fourth step? The receiver will send, we will choose another random value y equals to 6. This is the fourth step. Another value equals to another random number y equals to 6. He will calculate, fifth step is, he will calculate b value. What is the b value here? B equals to g power y mod n. So what is the value here? If we calculate, the value is 7 power 6 mod 11, that equals to 4. Okay, here a equals to 4, b equals to 4. And after that, in fifth step, in sixth step, the sender will send this value to B, receiver will send B value to A. So here both values are exchanging. Both values are exchanging. After exchanging, what happened here? Here B equals to 4 at receiver sender side, and receiver side A value equals to 2. A value equals to 2. And what about the sixth step? In sixth step, the sender will calculate K1 value. What is the K1 value? K1 B power X mod N. Okay, this is the formula for key K1. And what about seventh step? The seventh step is receiver will calculate K2 equals to A power by mod N. He will calculate the key 2. Okay, if you substitute these values here, K1 equals to 4 power 3 mod 11, that equals to 9. So what is the K value here? K value equals to 9. We got K value equals to 9. And what about receiver side? Receiver side, K2 equals to, we are calculating K2 value here, 2 power 6 mod 11, that equals to 9. So K2 equals to 9. So finally we are saying that K1 equals to K2. This condition is satisfied. So if the K1 equals to K2, the condition is satisfied, the key is successfully exchanged from sender to receiver. Okay, this is about the Diffie-Hellman key exchange algorithm. If you have any doubts, please ask me in comment section. Please like our videos and subscribe our YouTube channel, and also share. Hi everyone, welcome to my YouTube channel Concept Clear. In today's class, we will discuss about knapsack problem in cryptography. Okay, before starting our topic, we already studied what is knapsack in design analysis of algorithm subject. Okay, what is a knapsack? A knapsack is nothing but it is a container, it is a bag. Okay, here we have to fill our container or bag with several different items, and also we have to fill the bag with less than capacity with more value. Okay, suppose you went to a supermarket, you need to fill your bag with your capacity. It means how much capacity you can carry. Up to that capacity only you have to fill, and in that capacity also you have to fill all the house requirement items. Okay, this technology is called knapsack problem. This problem is called knapsack problem. Here the same knapsack problem is implemented in cryptography. What is a knapsack here? A knapsack is nothing but a public key cryptography or asymmetric key cryptography. What is the meaning of public key? What is the meaning of asymmetric? Means both are same. Here asymmetric means we have to use a pair of keys for encryption and decryption. Here we have to use a pair of keys, public key and private key for encryption and decryption. Okay, knapsack algorithm developed by Hellman and Ralph Markele. Okay, Hellman and Ralph Markele in 1978. In knapsack algorithm, we use two keys for encryption as well as the decryption. The first key is called public key. It is used for encryption. Second key is the private key. It is used for decryption. Here, how it will be performed? Here we will see one basic example for knapsack problem. Assume set of data weights 1, 6, 8, 15, 24. Assume these are the weights, and plain text is 1, 0, 1, 1, 0, 1, and I am taking one more set 1, 1, 0 1 0. Okay, this is the plain text. And how to convert this plain text with using these weights means, here we have to multiply each number, each plain text into with 8. Okay, we are multiplying means XOR operation, or multiplying with 1 into 1. What is the value here? We will get 1 into 1 1, 1 into 6. What is the value? 0. 1 in 0 into 8 0, and 1 into 15 15, and here 1 into 24 24. And what about here? 1 6 0 15, here 0 24 0. So what is the value if you are adding this all? The ciphertext is 1 plus 15 plus 24, that equals to, what is the value? 40. And what about here? Ciphertext is 1 plus 6 plus 15 22. So what is the ciphertext you are getting here? Ciphertext equals to plain text plus corresponding weights. What is the corresponding weights here? 40 comma 22 is the ciphertext. Okay, like this, the same concept were implemented in knapsack problem in cryptography. Okay, in this method, it contains 3 steps. It contains 3 steps. What are the 3 steps? First one is key generation. Second one is encryption, and third one is decryption. These are the 3 steps you have to execute in knapsack problem. First one is key generation, encryption, and decryption. We will see one by one. Okay, what is the first step? Key generation. What is the meaning of key generation? Here, to perform encryption and decryption, we have to generate a pair of keys. The first one is public key, the second one is the private key. So here we have to generate public key, second one is the private key. Okay, here public key will use hard knapsack problem, and private key used for easy knapsack problem. Okay, to calculate here, to calculate we need to take increasing algorithm values. Here we need to take increasing, sorry, to calculate we need to consider increasing order, increasing algorithm values, like example 1 4 8 15. Okay, we have to take like this. Okay, see here in example I am taking the values, increasing order values are 1 2 4 8 20 15 50. How these values are considered? Here the first value is 1, second value is 2. 1 plus 2 is 3. So we have to take the next value is more than 3. So 1 plus 3. So we are taking the fourth value. Next, here 8. What is the 8? 1 2 4. What is the 1 2 3 4? 1 2 plus 4 7. So next value is 8. So again here 8 plus 4 12 13 14 15. So I am taking the more than value 15. Like this we have to take increasing order values. Okay, this is the step 1. Step 2, we need to take m and n values. We need to take m and n values. Okay, and this is the first step. It is mandatory. It is mandatory to take this type of values, otherwise it won't give proper results. Okay, clear? And we need to take m and n value. How to take the m and n value? Here the m value has a condition, m always less than sum of all number of sequence values. It is a sequence value. For example, here what is the value here? Total value is 85. So the m value is greater than 85. For example, I am taking m equals to 110. Okay, I am taking m equals to 110. Okay, clear? So again, n value. What is n value here? N value I am taking 31. Why I am taking 31 means select it has no common factor m. It has no common factor m. We have to satisfy this condition. We have to take 11. So here I am taking the n value equals to 31. Okay, you can take any number if you want. Okay, and third step, generate public key. Generate public key based on private key. Private key D. What is the D here? Here D is 1, 2, 4, 8, 20 and 50. This is the private key. What are the example values are taking? Sequence value. That is the private key. Okay. Here what is the third step? Generate. To generate a formula is there for public key. Public key formula. Public key formula is di into n mod m. So di into m mod m. So what is the value di means? Di means these are all the values. For the first time, the first value, second time, second value, like that we have to consider. So what is the first value? Di means 1 into n value is 31 mod m value is what? M value is 110. Okay, if you calculate this one, 31 mod 110, that equals to 31. Okay, the remainder value we will consider here 31. Same, 2 into 31 mod 110, that equals to 62. Next, 4 into 31 mod 110. So what is the value here? 14. Next, 8 into 31 mod 110. What is the value here? We will get 28. Next value is 20 into 31 mod 110, that equals to 70. Next value is 50 into 31 mod 110, the value is 10. Okay, here we used all the private keys to generate the public key. So what is the public key here? The public key is 31, 62, 14, 28, 70 and 10. This is the public key based on private key. Okay, the based on private key we generated the public key. Next, what we have to do? We have to encrypt the data. What is the meaning of encryption? Encryption means what? Encryption. Second step is encryption. Okay, here encryption is nothing but what? Converting plain text to ciphertext is called encryption. So here I am taking, assume some random plain text. Assume plain text is, I am taking the plain text is 1 0 0 1 0 1 1 0 1 1 0 0 and 1 1 1 1 0 0. Here I am taking here 6-digit plain text, because in private key I took total 6 values. So here also we have to take 6-digit plain text. Okay, suppose if you take in the private key value 4 digits, here also plain text will be 4 digits. According to plain text, we have to take the same number of plain text. Sorry, according to private key, we have to take the same size of the same number of plain text size. Okay, here sequence is 6, so here also I am taking the sequence is 6. Suppose if you take 5, here also we have to take 5 values. Suppose if you take 7, here also we have to take 7. Okay, here next I am taking here these 3 values like this. This is the first plain text 1 0 0 1 0 1. This is the first part, and 1 0 1 1 0 0 second part, and third part is okay. Assume this is the first part, second part, third part. Okay, next what is the first part? The first part is 1 0 0 1 0 1. Here what is the what is the public key generated? The public key is 31. So we have to add 1 into 31 plus 0 into 62. Every bit will be added with public key, plus 0 into 14 plus 1 into 28 plus 0 into 70 plus 1 into 10. If we add this all, we will get 69. So what is the first part of private ciphertext is 69. Okay, clear. And what about second part? Second part is 101100. Again we have to add every plain text with public key. Okay, what is the first value? 1 into 31 plus 0 into 62 plus 1 into 14 plus 1 into 28 plus 0 into 70 plus 1 into 0 into 10. What is the value here? We will get 73. That is the second ciphertext is 73, and third ciphertext we have to calculate. And third value, if we calculate 111100, if we calculate, we will get 135. For time being, I am writing directly 135. Okay, clear. So what is the ciphertext here? Ciphertext is 69, 73, 135. That is the ciphertext we got. Okay, this is about the encryption algorithm. And next one is decryption algorithm. In decryption algorithm, what is the decryption algorithm? Decryption algorithm is nothing but converting ciphertext into plain text is called decryption algorithm. In decryption algorithm, we need to take ciphertext and we have to get plain text. Okay, here we have to calculate n inverse value. N inverse value. Here, what is the n value? In previous example, in plain text, we will consider n value equals to 31. So we have to calculate the n inverse value. 31 into x mod 110 equals to 1. This condition has to be satisfied. Here we need to check x value equals to 1, 2, 3 up to n value, where the condition will be satisfied. Okay, for time being I am telling here the n value will be satisfied, n equals to 1, then this condition will be true. So what is the n value? 71. So what is the plain text? To convert the ciphertext into plain text means plain text equals to ciphertext into x mod m. This is the formula for plain text. What is the formula here? Ciphertext into x mod m. So if you are implementing this ciphertext in this formula, you will get the plain text. So the first one is 69 into x value is 71. 69 into 71 mod 110, that equals to what? That equals to 59. And this 59, how to write in how to write this 59? This 59 can be written as, this 59 will be uh, written as in this format, in this method. How to write this 59 in this sequencing order? Sequencing order. How to write 59 means we have to write the 59 is 1 plus 8 plus 50. 1 plus 8 plus 50. So what is the 1 plus 8 plus 50? This is the sequencing, increasing sequencing order. Okay, here, where is the 1? In the example, where is the 1? First one is the 1. So, what is the value here? 1, 0, 0. Eighth value is 1. 1, 0, 1. Okay, if you compare with the plain, if you compare this private key, you will get 1850 means the data will be converted as 100101. Okay, here where is the 1? Same place we got the 1, 1, 1. So remaining all the zeros. So this is the 100101. Okay, and what about the second step? What is the second value? Second value is 73 into 71 mod 110, that equals to 13. How to write this 13? 1 plus 4 plus 18. And where is the, which values are satisfying here? Put the ones, remaining zeros. So we will get 101100. And whatever the last one is, so 135 into 71 mod 110, that equals to 15. So what is the value? 1 plus 2 plus 4 plus 8, that equals to 15. Where these values here? All the first four sequences are, first four are 1. Remaining zeros, 1, 1, 1, 1, 0, 0. So what is the plain text here? First value for plain text is 1001, 101. We are getting here. So these are the plain text. Okay, see here. These three are the plain text. Okay, and the cipher, this is the plain text we are considered. After this plain text is converted as the 69, 73, 135. Again in decryption, we are getting the plain text value as original. This is the first part plain text, second part third part. Okay, this is about the knapsack problem in cryptography. Okay, if you please like our videos and subscribe our YouTube channel. Thank you everyone.
నా ఛానల్ పేరు గుర్తుందిగా, ప్లీజ్ లైక్, షేర్ అండ్ సబ్స్క్రైబ్.